This finding may have considerable relevance for humans even though these were rat studies. I say this because the protein required for growth in young rats and humans, as well as the protein required to maintain health for adult rats and humans, is remarkably similar. 0.4041. According to the recommended daily allowance, RDA, for protein consumption, we humans should be getting about 10% of our energy from protein. This is considerably more than the actual amount required. But because requirements may vary from individual to individual, 10% dietary protein is recommended to ensure adequate intake for virtually all people. What do most of us routinely consume? Remarkably, it is considerably more than the recommended 10%. The average American consumes 15 to 16% protein. Does this place us at risk for getting cancer? These animal studies hint that it does. 10% dietary protein is equivalent to eating about 50 to 60 grams of protein per day, depending on body weight and total calorie intake. The national average of 15 to 16% is about 70 to 100 grams of protein per day, with men at the upper part of the range and women at the lower end. In food terms, there are about 12 grams of protein in 100 calories of spinach, 15 ounces, and 5 grams of protein in 100 calories of raw chickpeas. Just over 2 tablespoons. There are about 13 grams of protein in 100 calories of porterhouse steak, just over 1.5 ounces. Yet another question was whether protein intake could modify the all-important relationship between aflatoxin dose and foci formation. A chemical is usually not considered a carcinogen unless higher doses yield higher incidences of cancer. For example, as the aflatoxin dose becomes greater, foci and tumor growth should be correspondingly greater. If an increasing response is not observed for a suspect chemical carcinogen, serious doubt arises whether it really is carcinogenic. To investigate this dose-response question, 10 groups of rats were administered increasing doses of aflatoxin, then fed either regular levels, 20%, or low levels, 5 to 10%, of protein during the promotion period. Chart 3.734. In the animals fed the 20% level of protein, foci increased in number and size, as expected, as the aflatoxin dose was increased. The dose response. Turning off cancer. Chart 3.7, aflatoxin dose foci response. 200, 235, 275, 300, 350. Aflatoxin dose, mcg/kg body weight/day. 20% protein. 5% protein. 59. Relationship was strong and clear. However, in the animals fed 5% protein, the dose-response curve completely disappeared. There was no foci response, even when animals were given the maximum tolerated aflatoxin dose. This was yet another result demonstrating that a low-protein diet could override the cancer-causing effect of a very powerful carcinogen, aflatoxin. Is it possible that chemical carcinogens, in general, do not cause cancer unless the nutritional conditions are right? Is it possible that, for much of our lives, we are being exposed to small amounts of cancer-causing chemicals, but cancer does not occur unless we consume foods that promote and nurture tumor development? Can we control cancer through nutrition? Not all proteins are alike. If you have followed the story so far, you have seen how provocative these findings are. Controlling cancer through nutrition was, and still is, a radical idea. But as if this weren't enough, one more issue would yield explosive information. Did it make any difference what type of Protein was used in these experiments. For all of these experiments, we were using casein, which makes up 87% of cow's milk protein. So, the next logical question was whether plant protein, tested in the same way, has the same effect on cancer promotion as casein. The answer is an astonishing no. In these experiments, plant protein did not promote cancer growth, even at the higher levels of intake. An undergraduate pre-medical student doing an honors degree with me, David Schulsinger, did the study, chart 3.842. Gluten, the protein of wheat, did not produce the same result as casein, even when fed at the same 20% level. 60. The China study. Chart 3.8, protein type and foci response. LD50 20% casein, 20% gluten, 0.5% casein. Protein type. We also examined whether soy protein had the same effect as casein on foci development. Rats fed 20% soy protein diets did not form early foci, just like the 20% wheat protein diets. Suddenly protein, milk protein in this case, wasn't looking so good. We had discovered that low protein intake reduces cancer initiation and works in multiple synchronous ways. As if that weren't enough, we were finding that high protein intake, in excess of the amount needed for growth, promotes cancer after initiation. Like flipping a light switch on and off, we could control cancer promotion merely by changing levels of protein, regardless of initial carcinogen exposure. But the cancer-promoting factor in this case was cow's milk protein. It was difficult enough for my colleagues to accept the idea that protein might help cancer grow, but cow's milk protein? Was I crazy? Additional questions. For those readers who want to know somewhat more, I've included a few questions in Appendix A. The grand finale. Thus far we had relied on experiments where we measured only the early indicators of tumor development, the early cancer-like foci. Now, it was time to do the big study, the one where we would measure complete tumor formation. We organized a very large study of several hundred rats and examined tumor formation over their lifetimes using several different approaches. 36, 43. Turning off cancer 61. The effects of protein feeding on tumor development were nothing less than spectacular. Rats generally live for about 2 years, thus the study was 100 weeks in length. All animals that were administered aflatoxin and fed the regular 20% levels of casein either were dead or near death from liver tumors at 100 weeks. 36. 43. All animals administered the same level of aflatoxin but fed the low 5% protein diet were alive, active, and thrifty, with sleek hair coats at 100 weeks. This was a virtual 102 score, something almost never seen in research and almost identical to the original research in India. 16. In this same experiment 36 we switched the diets of some rats at either 40 or 60 weeks, to again investigate the reversibility of cancer promotion. Animals switched from a high protein to a low protein diet had significantly less tumor growth, 35 degree TB 40% less, than animals fed a high protein diet. Animals switched from a low protein diet to a high protein. Chart 3.98, tumor development at 100 weeks. QJ 3336. Chart 3.98, early foci, LLFETIME. Percent dietary casein. 62. The China study. diet halfway through their lifetime started growing tumors again. These findings on full-blown tumors confirmed our earlier findings using foci. Namely, nutritional manipulation can turn cancer on and off. We also measured early foci in these lifetime studies to see if their response to dietary protein was similar to that for tumor response. The correspondence between foci growth and tumor growth could not have been greater. Chart 3. 9a. 36,43. How much more did we need to find out? I would never have dreamed that our results up to this point would be so incredibly consistent, biologically plausible, and statistically significant. We had fully confirmed the original work from India and had done it in exceptional depth. Let there be no doubt, cow's milk protein is an exceptionally potent cancer promoter in rats dosed with aflatoxin. The fact that this promotion effect occurs at dietary protein levels 0–20%, commonly used both in rodents and humans, makes it especially tantalizing and provocative. Other cancers, other carcinogens. Okay, so here's the central question: how does this research apply to human health and human liver cancer in particular? One way to investigate this question is to research other species, other carcinogens and other organs. If casein's effect on cancer is consistent across these categories, it becomes more likely that humans better take note. So our research became broader in scope, to see whether our discoveries would hold up. While our rat studies were underway, studies were published 44,45. Claiming that chronic infection with hepatitis B virus, HBV, was the major risk factor for human liver cancer. It was thought that people who remained chronically infected with HBV had 20 to 40 times the risk of getting liver cancer. Over the years, considerable research had been done on how this virus causes liver cancer. 46 In effect, a piece of the virus gene inserts itself into the genetic material of the mouse liver where it initiates liver cancer. When this is done experimentally, the animals are considered transgenic. Virtually all of the research done in other laboratories on HBV transgenic mice, and there was a lot of it, was done primarily to understand the molecular mechanism by which HBV worked. No attention was given to nutrition and its effect on tumor development. I watched with some amusement for several years how one community of researchers argued for aflatoxin as the key cause of human liver cancer and another turning off cancer 63 community argued for HBV. No one in either community dared to suggest that nutrition had anything to do with this disease. We wanted to know about the effect of casein on HBV-induced liver cancer in mice. This was a big step. It went beyond aflatoxin as a carcinogen and rats as a species. A brilliant young graduate student from China in my group, Jifen Hu, initiated studies to answer this question and was later joined by doctors Haiqiang Chen. We needed a colony of these transgenic mice. There were two such breeds of mice, one living in La Jolla, California, the other in Rockville, Maryland. Each strain had a different piece of HBV gene stuck in the genes of their livers, and each was therefore highly prone to liver cancer. I contacted the responsible researchers and inquired about their helping us to establish our own mouse colony. Both research groups asked what we wanted to do, and both were inclined to think that studying the protein effect was foolish. I also sought a research grant to study this question, and it was rejected. The reviewers did not take kindly to the idea of a nutritional effect on a virus-induced cancer, especially of a dietary protein effect. I was beginning to wonder, was I now being too explicit in questioning the mythical health value of protein? The reviews of the grant proposal certainly indicated this possibility. We eventually obtained funding, did the study on both strains of mice and got essentially the same result as we did with the rats. 47-48. You can see the results for yourself. The adjoining picture, chart 3.1047, shows what a cross-section of the mouse livers looks like under a microscope. The dark-colored material is indicative of cancer development. Ignore the hole, that's only a cross-section of a vein. There is intense early cancer formation in the 22% casein animals, D, much less in the 14% casein animals, C, and none in the 6% casein animals, B. The remaining picture, A, shows a liver having no virus gene, the control. The adjoining graph, chart 3.1147, shows the expression, activity, of two HPV genes that cause cancer inserted in the mouse liver. Both the picture and the graph show the same thing, the 22% casein diet turned on expression of the viral gene to cause cancer, whereas the 6% casein diet showed almost no such activity. By this time, we had more than enough information to conclude that casein, that sacred protein of cow's milk, dramatically promotes liver cancer in rats dosed with aflatoxin. Mice infected with HPV 64. The China study. Chart 3.10, dietary protein effect on genetically based HPV, liver cancer, mice. Non-transgenic mice. Control, with 22% casein diet. Transgenic mice with 14% casein diet. Transgenic mice with 6% casein diet. Chart 3.11, dietary protein effect on gene expression, mice. Turning off cancer 65. Not only are these effects substantial, but we also discovered a network of complementary ways by which they worked. Next question, can we generalize these findings to other cancers and to other carcinogens? At the University of Illinois Medical Center in Chicago, another research group was working with mammary, breast cancer in rats. 49-51. This research showed that increasing intakes of casein promoted the development of mammary, breast cancer. They found that higher casein intake promotes breast cancer in rats dosed with two experimental carcinogens, 7,12-dimethibens, A, anthracene, DBMA, and N-nitrosomethylurea, NMU. Operates through a network of reactions that combine to increase cancer. Operates through the same female hormone system that operates in humans. Larger implications. An impressively consistent pattern was beginning to emerge. For two different organs, 4 different carcinogens and 2 different species. Casein promotes cancer growth while using a highly integrated system of mechanisms. It is a powerful, convincing and consistent effect. 4. Example, casein affects the way cells interact with carcinogens, the way DNA reacts with carcinogens and the way cancerous cells grow. The depth and consistency of these findings strongly suggest that they are relevant for humans, for 4 reasons. First, rats and humans have an almost identical need for protein. Second, protein operates in humans virtually the same way it does in rats. Third, the level of protein intake causing tumor growth is the same level that humans consume. And fourth, in both rodents and humans the initiation stage is far less important than the promotion stage of cancer. This is because we are very likely dosed with a certain amount of carcinogens in our everyday lives, but whether they lead to full tumors depends on their promotion. or lack thereof. Even though I became convinced that increasing casein intake promotes cancer, one still had to be wary of generalizing too much. This was an exceptionally provocative finding that drew fierce skepticism. But these findings nonetheless were a hint of things to come. I wanted to broaden my evidence still more. What effect did other nutrients have on Can 66 the China study? Sir, and how did they interact with different carcinogens and different organs? Might the effects of other nutrients, carcinogens, or organs cancel each other, or might there be consistency of effect for nutrients within certain types of food? Would promotion continue to be reversible? If so, cancer might be readily controlled, even reversed, simply by decreasing the intakes of the promoting nutrients and or increasing the intakes of the anti-promoting nutrients. We initiated more studies using several different nutrients, including fish protein, dietary fats, and the antioxidants known as carotenoids. A couple of excellent graduate students of mine, Tom O'Connor and Yu-Ping He, measured the ability of these nutrients to affect liver and pancreatic cancer. The results of these, and many other studies, showed nutrition to be far more important in controlling cancer promotion than the dose of the initiating carcinogen. The idea that nutrients primarily affect tumor development during promotion was beginning to appear to be a general property of nutrition and cancer relationships. The Journal of the National Cancer Institute, which is the official publication of the U.S. National Cancer Institute, took note of these studies and featured some of our findings on its cover. Point 52. Furthermore, a pattern was beginning to emerge. Nutrients from animal-based foods increased tumor development while nutrients from plant-based foods decreased tumor development. In our large lifetime study of rats with aflatoxin-induced tumors, the pattern was consistent. In mice with hepatitis B virus-altered genes, the pattern was consistent. In studies done by another research group, with breast cancer and different carcinogens, the pattern was consistent. In studies of pancreatic cancer and other nutrients, the pattern was consistent. Point 52,53 in studies on carotenoid antioxidants and cancer initiation, the pattern was consistent. 54,55 from the first stage of cancer initiation to the second stage of cancer promotion, the pattern was consistent. From one mechanism to another, the pattern was consistent. So much consistency was stunningly impressive, but one aspect of this research demanded that we remain cautious. All this evidence was gathered in experimental animal studies. Although there are strong arguments that these provocative findings are qualitatively relevant to human health, we cannot know the quantitative relevance. In other words, are these principles regarding animal protein and cancer critically important for all humans in all situations, or are they merely marginally important for a minority of people in fairly unique situations? Are these turning off cancer 67 sipples involved in 1,000 human cancers every year, 1 million human cancers every year, or more? We need direct evidence from human research. Ideally, this evidence would be gathered with rigorous methodology and would investigate dietary patterns comprehensively. Using large numbers of people who had similar lifestyles, similar genetic backgrounds, and yet had widely varying incidences of disease. Having the opportunity to do such a study is rare, at best, but by incredibly good luck we were given exactly the opportunity we needed. In 1980 I had the good fortune of welcoming in my laboratory a most personable and professional scientist from mainland China, Dr. Junqi Chen. With this remarkable man, opportunities arose to search for some larger truths. We were given the chance to do a human study that would take all of these principles we had begun to uncover in the lab to the next level. It was time to study the role of nutrition, lifestyle, and disease in the most comprehensive manner ever undertaken in the history of medicine. We were on to the China study. Lessons from China. A snapshot in time. Have you ever had the sensation of wanting to permanently capture a moment? Such moments can grip you in a way you will never forget. For some people, those moments center on family, close friends, or related activities. For others, those moments may center on nature, spirituality, or religion. For most of us, I suspect, it can be a little of each. They become the personal moments, both happy and sad, which define our memories. It's these moments in which everything just comes together. They are the snapshots of time that define much of our life experience. The value of a snapshot of time is not lost on researchers either. We construct experiments, hoping to preserve and analyze the specific details of a certain moment for years to come. I was fortunate enough to be privy to such an opportunity in the early 1980s, after a distinguished senior scientist from China, Dr. Junqi Chen, came to Cornell to work in my lab. He was deputy director of China's premier health research laboratory and one of the first handful of Chinese scholars to visit the U.S. following the establishment of relations between our two countries. The Cancer Atlas. In the early 1970s, the premier of China, Zhou Enlai, was dying of cancer. In the grips of this terminal disease, Premier Zhou initiated a nationwide survey to collect information about a disease that was not 69. 70 The China study. Well understood. It was to be a monumental survey of death rates for 12 different kinds of cancer for more than 2,400 Chinese counties. And 880 million, 96%, of their citizens. The survey was remarkable in many ways. It involved 650,000 workers, the most ambitious biomedical research project ever undertaken. The end result of the survey was a beautiful, color-coded atlas showing where certain types of cancer were high and where they were almost non-existent. 1. Chart 4.1, Sample Cancer Atlas in China. Colon and rectum, female. This atlas made it clear that in China cancer was geographically localized. Some cancers were much more common in some places than in others. Earlier studies had set the stage for this idea, showing that cancer incidence also varies widely between different countries. 2. -4 But these China data were more remarkable because the geographic variations in cancer rates were much greater. Chart 4.2. They also occurred in a country where 87% of the population is the same ethnic group, the Han people. Lessons from China 71. Chart 4.2. Range of cancer rates in Chinese counties. Cancer site males females. All cancers 35 to 721, 35 to 491. Nasopharynx 0 to 75, 0 to 26. Esophagus 1 to 435, 0 to 286. Stomach 6 to 386, 2 to 141. Liver 7 to 248, 3 to 67. Colorectal 2 to 67, 2 to 61. Lung 3 to 59, 0 to 26. Breast 0 to 20. Asterisk age-adjusted death rates, representing hashtag cases /L00,000 people/year. Why was there such a massive variation in cancer rates among different counties when genetic backgrounds were similar from place to Place. Might it be possible that cancer is largely due to environmental lifestyle factors, and not genetics? A few prominent scientists had already reached that conclusion. The authors of a major review on diet and cancer, prepared for the U.S. Congress in 1981, estimated that genetics only determines about 2 to 3% of the total cancer risk. 4. The data behind the China Cancer Atlas were profound. The counties with the highest rates of some cancers were more than 100 times greater than counties with the lowest rates of these cancers. These are truly remarkable figures. By way of comparison, we in the U.S. see, at most, 2 to 3 times the cancer rates from one part of the country to another. In fact, very small and relatively unimportant differences in cancer rates make big news, big money, and big politics. There has been a long-standing story in my state of New York about the increased rates of breast cancer in Long Island. Large amounts of money, about $30 million, and years of work have been spent examining the issue. What sorts of rates were causing such a furor? 2 counties in Long Island had rates of breast cancer only 10 to 20% higher than the state average. This difference was enough to make front-page news, scare people, and move politicians to action. Contrast this with the findings in China, where some parts of the country had cancer rates 100 times, 10,000% higher than others. 72. The China study. Because China is relatively homogeneous genetically, it was clear that these differences had to be explained by environmental causes. This raised a number of critical questions. Why was cancer so high in some rural Chinese counties and not in others? Why were these differences so incredibly large? Why was overall cancer, in the aggregate, less common in China than in the U.5? The more Dr. Chen and I talked, the more we wished that we had a snapshot in time of the dietary and environmental conditions in rural China. If only we could look into these people's lives, note what they eat, how they live, what is in their blood and their urine, and how they die. If only we could construct a picture of their experience with unprecedented clarity and detail so that we could study it for years to come. If we could do that, we might be able to offer some answers to our why questions. Occasionally science, politics, and financing come together in a way that allows a truly extraordinary study to take place. This happened for us, and we got the opportunity to do everything we wanted, and more. We were able to create the most comprehensive snapshot of diet, lifestyle, and disease ever taken. Pulling it together, we assembled a world-class scientific team. There was Dr. Chen, who was the deputy director of the most significant government diet and health research laboratory in all of China. We enlisted Dr. Jinyoli, one of the authors of the Cancer Atlas Survey and a key scientist in China's Academy of Medical Sciences in the Ministry of Health. The third member was Richard Peto of Oxford University. Considered one of the premier epidemiologists in the world, Peto has since been knighted and has received several awards for cancer research. I rounded out the team as the project director. Everything was coming together. It was to be the first major research project between China and the United States. We cleared the necessary funding hurdles, weathering both CIA intrusiveness and Chinese government reticence. We were on our way. We decided to make the study as comprehensive as possible. From the Cancer Atlas, we had access to disease mortality rates on more than lessons from China 73. 4 dozen different kinds of disease, including individual cancers, heart diseases and infectious diseases. 6. We gathered data on 367 variables and then compared each variable with every other variable. We went into 65 counties across China and administered questionnaires and blood tests on 6,500 adults. We took urine samples directly, measured everything families ate over a 3-day period, and analyzed food samples from marketplaces around the country. The 65 counties selected for the study were located in rural to semi-rural parts of China. This was intentionally done because we wanted to study people who mostly lived and ate food in the same area for most of their lives. This was a successful strategy, as we were to learn that an average of 90 to 94% of the adult subjects in each county still lived in the same county where they were born. When we were done, we had more than 8,000 statistically significant associations between lifestyle, diet, and disease variables. We had a study that was unmatched in terms of comprehensiveness, quality, and uniqueness. We had what the New York Times termed the Grand Prix of epidemiology. In short, we had created that revealing snapshot of time that we had originally envisioned. This was the perfect opportunity to test the principles that we discovered in the animal experiments. Were the findings in the lab going to be consistent with the human experience in the real world? Were our discoveries on aflatoxin-induced liver cancer in rats going to apply to other types of cancer and other types of diseases in humans? For more information, we take great pride in the comprehensiveness and quality of the China study. To see why, read Appendix B on page 353. You'll find a more complete discussion of the basic design and characteristics of the study. The Chinese dietary experience. Critical to the importance of the China study was the nature of the diet consumed in rural China. It was a rare opportunity to study health-related effects of a mostly plant-based diet. In America, 15 to 16% of our total calories comes from protein, and upwards of 80% of this amount comes from animal-based foods. But in 74, the China study, rural China, only 9 to 10% of total calories comes from protein, and only 10% of the protein comes from animal-based foods. This means that there are major nutritional differences in the Chinese and American diets, as shown in Chart 4.3. Chart 4.3. Chinese and American dietary intakes. Nutrient China, United States. Calories, kcal/Davy 2641 1989. Total fat, percent of calories, 14.534 to 38. Dietary fiber, G/Day, 3312. Total protein, G/Day, 6491. Animal protein, percent of 0.810 to 11. Calories. Total iron, mg/Day, 3418. The findings shown in Chart 4.3 are standardized for a body weight of 65 kilograms, 143 pounds. This is the standard way that Chinese authorities record such information, and it allows us to easily compare different populations. For an American adult male of 77 kilograms, calorie intake will be about 2,400 calories per day. For an average rural Chinese adult male of 77 kilograms, calorie intake will be about 3,000 calories per day. In every category seen above, there are massive dietary differences between the Chinese and American experiences, much higher overall calorie intake, less fat, less protein, much less animal foods, more fiber, and much more iron are consumed in China. These dietary differences are supremely important. While the eating pattern in China is far different from that of the United States, there is still a lot of variation within China. Experimental variation, i.e., a range of values, is essential when we investigate diet and health associations. Fortunately, in the China study considerable variation existed for most of the measured factors. There was exceptional variation in disease rates, chart 4.2, and more than adequate variation for clinical measurements and food intakes. For example, blood cholesterol ranged as county averages from highest to lowest almost twofold, blood beta-carotene about ninefold, blood lipids about threefold, fat intake about sixfold, and fiber intake about fivefold. This was Lessons from China 75. Crucial, as we primarily were concerned with comparing each county in China with every other county. Ours was the first large study that investigated this particular range of dietary experience and its health consequences. In effect, we are comparing, within the Chinese range, diets rich in plant-based foods to diets very rich in plant-based foods. In almost all other studies, all of which are Western, scientists are comparing diets rich in animal-based foods to diets very rich in animal-based foods. The difference between rural Chinese diets and Western diets, and the ensuing disease patterns, is enormous. It was this distinction, as much as any other, that made this study so important. The media called the China study a landmark study. An article in the Saturday Evening Post said the project should shake up medical and nutrition researchers everywhere, ate some in the medical establishment. Said another study like this could never be done. What I knew was that our study offered an opportunity to investigate many of the most contentious ideas that I was forming about food and health. Now, I want to show you what we learned from this study and how 20 more years of research, thought and experience have changed not only the way I think about the connection between nutrition and health, but the way my family and I eat as well. Diseases of poverty and affluence. It doesn't take a scientist to figure out that the possibility of death has been holding pretty steady at low % for quite some time. There's only one thing that we have to do in life, and that is to die. I have often met people who use this fact to justify their ambivalence toward health information. But I take a different view. I have never pursued health hoping for immortality. Good health is about being able to fully enjoy the time we do have. It is about being as functional as possible throughout our entire lives and avoiding crippling, painful and lengthy battles with disease. There are many better ways to die and to live. Because the China Cancer Atlas had mortality rates for more than 4 dozen different kinds of disease, we had a rare opportunity to study the many ways that people die. We wondered, do certain diseases tend to group together in certain areas of the country? For example, did colon cancer occur in the same regions as diabetes? If this proved to be the case, we could assume that diabetes and colon cancer, or other diseases that group together, shared common causes. These causes, 76 the China study, could include a variety of possibilities, ranging from the geographic and environmental to the biological. However, because all diseases are biological processes gone awry, we can assume that whatever causes are observed, they will eventually operate through biological events. When these diseases were cross-listed in a way that allowed every disease rate to be compared with every other disease rate, 2 groups of diseases emerged, those typically found in more economically developed areas, diseases of affluence, and those typically found in rural agricultural areas, diseases of poverty, 10. Chart 4.4. Chart 4.4. Disease groupings observed in rural China. Diseases of affluence: cancer, colon, lung, breast, leukemia. Nutritional extravagance: childhood brain, stomach, liver, diabetes, coronary heart disease. Diseases of poverty: nutritional pneumonia, intestinal obstruction, inadequacy and poor sanitation, peptic ulcer, digestive disease. Pulmonary tuberculosis, parasitic disease, rheumatic heart disease, metabolic and endocrine disease other than diabetes, diseases of pregnancy, and many others. Chart 4.4 shows that each disease, in either list, tends to associate with diseases in its own list but not in the opposite list. A region in rural China that has a high rate of pneumonia, for example, will not have a high rate of breast cancer, but will have a high rate of a parasitic disease. The disease that kills most Westerners, coronary heart disease, is more common in areas where breast cancer also is more common. Coronary heart disease, by the way, is relatively uncommon in many developing societies of the world. This is not because people die at a younger age, thus avoiding these Western diseases. These comparisons are age standardized rates, meaning that people of the same age are being compared. Disease associations of this kind have been known for quite some time. What the China study added, however, was an unsurpassed amount of data on death rates for many different diseases and a unique range of dietary experience. As expected, certain diseases do cluster together in the same geographic areas, implying that they have shared causes. These two disease groups have usually been referred to as diseases of lessons from HENA 77, affluence, and diseases of poverty. As a developing population accumulates wealth, people change their eating habits, lifestyles, and sanitation systems. As wealth accumulates, more and more people die from rich diseases of affluence than poor diseases of poverty. Because these diseases of affluence are so tightly linked to eating habits, diseases of affluence might be better named diseases of nutritional extravagance. The vast majority of people in the United States and other Western countries die from diseases of affluence. For this reason, these diseases are often referred to as Western diseases. Some rural counties had few diseases of affluence while other counties had far more of these diseases. The core question of the China study was this: is it because of differences in dietary habits? Statistical significance. As I go through this chapter, I will indicate the statistical significance of various observations. Roman numeral 1, I, means 95+%. Certainty, Roman numeral 2, 2, means 99+% certainty, and Roman numeral 3, 3, means 99.9+% certainty. No Roman numeral means that the association is something less than 95% certainty. LL. These probabilities also can be described as the probability that an observation is real. A 95% certainty means a 19 in 20 probability that the observation is real. A 99% certainty means a 99 in 100 probability that the observation is real, and a 99.9% certainty means a 999 in 1000 probability that the observation is real. Blood cholesterol and disease. We compared the prevalence of Western diseases in each county with diet and lifestyle variables, and, to our surprise, we found that one of the strongest predictors of Western diseases was blood cholesterol. Leading in your food in your blood. There are two main categories of cholesterol. Dietary cholesterol is present in the food we eat. It is a component of food, much like sugar, fat, protein, vitamins and minerals. This cholesterol is found only in animal-based food and is the one we find on food labels. How much dietary cholesterol you consume is not something your doctor can know when he or she checks your cholesterol levels. The doctor can't. 78. The China study measure dietary cholesterol any more than he or she can measure how many hot dogs and chicken breasts you've been eating. Instead, the doctor measures the amount of cholesterol present in your blood. This second type of cholesterol, blood cholesterol, is made in the liver. Blood cholesterol and dietary cholesterol, although chemically identical, do not represent the same thing. A similar situation occurs with fat. Dietary fat is the stuff you eat, the grease on your French fries, for example. Body fat, on the other hand, is the stuff made by your body, and is very different from the fat that you spread on your toast in the morning, butter or margarine. Dietary fats and cholesterol don't necessarily turn into body fat and blood cholesterol. The way the body makes body fat and blood cholesterol is extremely complex, involving hundreds of different chemical reactions and dozens of nutrients. Because of this complexity, the health effects of eating dietary fat and dietary cholesterol may be very different from the health effects of having high blood cholesterol, what your doctor measures, or having too much body fat. As blood cholesterol levels in rural China rose in certain counties, the incidence of Western diseases also increased. What made this so surprising was that Chinese levels were far lower than we had expected. The average level of blood cholesterol was only 127 mg/dl, which is almost 100 points less than the American average, 215 mg/dl. 12 some counties had average levels as low as 94 mg/dl. For two groups of about 25 women in the inner part of China, average blood cholesterol was at the amazingly low level of 80 mg/dl. If you know your own cholesterol levels, you'll appreciate how low these values really are. In the US, our range is around 170-290 mg/dl. Our low values are near the high values for rural China. Indeed, in the US, there was a myth that there might be health problems if cholesterol levels were below 150 mg/dl. If we followed that line of thinking, about 85% of the rural Chinese would appear to be in trouble. But the truth is quite different. Lower blood cholesterol levels are linked to lower rates of heart disease, cancer, and other Western diseases, even at levels far below those considered safe in the West. At the outset of the China study, no one could or would have predicted that there would be a relationship between cholesterol and any of the disease rates. What a surprise we got. As blood cholesterol levels decreased from 170 mg/dl to 90 mg/dl, cancers of the liver 1 eye, rectum/colon, 2 male lung, female lung, breast, childhood leukemia. Lessons from China 79. Adult leukemia 1 childhood brain, adult brain 1 stomach and esophagus, throat, decreased. As you can see, this is a sizable list. Most Americans know that if you have high cholesterol, you should worry about your heart, but they don't know that you might want to worry about cancer as well. There are several types of blood cholesterol, including LDL and HDL. Cholesterol. LDL is the bad kind and HDL is the good kind. In the China study, higher levels of the bad LDL cholesterol also were associated with Western diseases. Keep in mind that these diseases, by Western standards, were relatively rare in China and that blood cholesterol levels were quite low. By Western standards, our findings made a convincing case that many Chinese had an advantage at the lower cholesterol levels, even below 170 mg/LDL. Now imagine a country where the inhabitants had blood cholesterol levels far higher than the Chinese average. You might expect that these relatively rare diseases, such as heart disease and some cancers, would be prevalent, perhaps even the leading killers. Of course, this is exactly the case in the West. To give a couple of examples, at the time of our study, the death rate from coronary heart disease was 17 times higher among American men than rural Chinese men. 13. The American death rate from breast cancer was 5 times higher than the rural Chinese rate. Even more remarkable were the extraordinarily low rates of coronary heart disease, CHD, in the southwestern Chinese provinces of Sichuan and Guizhou. During a 3-year observation period, 1973 to 1975, there was not one single person who died of CHD before the age of 64, among 246,000 men in a Guizhou County and 181,000 women in a Sichuan County. 14. After these low cholesterol data were made public, I learned from 3 very prominent heart disease researchers and physicians, Drs. Bill Castelli, Bill Roberts, and Caldwell Esselstyn, Jr., that in their long careers they had never seen a heart disease fatality among their patients who had blood cholesterol levels below 150 mg/LDL. Dr. Castelli was the longtime director of the famous Framingham Heart Study of NIH. Dr. Esselstyn was a renowned surgeon at the Cleveland Clinic who did a remarkable study reversing heart disease. Chapter 5. Dr. Roberts has long been editor of the prestigious medical journal Cardiology. 80. The China Study. Blood cholesterol and diet. Blood cholesterol is clearly an important indicator of disease risk. The big question is, how will food affect blood cholesterol? In brief, animal-based foods were correlated with increasing blood cholesterol. Chart 4.5. With almost no exceptions, nutrients from plant-based foods were associated with decreasing levels of blood cholesterol. Several studies have now shown, in both experimental animals and in humans, that consuming animal-based protein increases blood cholesterol levels. 1's 18 saturated fat and dietary cholesterol also raise blood cholesterol, although these nutrients are not as effective at doing this as is animal protein. In contrast, plant-based foods contain no cholesterol and, in various other ways, help to decrease the amount of cholesterol made by the body. All of this was consistent with the findings from the China study. Chart 4.5. Foods associated with blood cholesterol. As intakes of meat, milk, eggs, fish, fat and blood cholesterol goes up, animal protein go up. As intakes of plant-based foods and nutrients, blood cholesterol goes down. Eluting plant protein, dietary fiber, cellulose, hemicellulose, soluble carbohydrate, B vitamins of plants, carotenes, B2, B3, legumes, light colored vegetables, fruit, carrots, potatoes and several cereal grains, go up. These disease associations with blood cholesterol were remarkable because blood cholesterol and animal-based food consumption both were so low by American standards. In rural China, animal protein intake, for the same individual, averages only 7.1 kcal, whereas Americans average a whopping 70 kcal. To put this into perspective, 7 grams of animal protein is found in about 3 chicken nuggets from McDonald's. We expected that when animal protein consumption and blood cholesterol levels were as low as they are in rural China, there would be no further association with the Western diseases. But we were wrong. Even these small amounts of animal-based food in rural China raised the risk for Western diseases. We studied dietary effects on the different types of blood cholesterol. The same dramatic effects were seen. Animal protein consumption by lessons from China 81. Men was associated with increasing levels of bad blood cholesterol IIL, whereas plant protein consumption was associated with decreasing levels of this same cholesterol. 2. Walk into almost any doctor's office and ask which dietary factors affect blood cholesterol levels, and he or she will likely mention saturated fat and dietary cholesterol. In more recent decades, some might also mention the cholesterol-lowering effect of soy or high-fiber brand products, but few will say that animal protein has anything to do with blood cholesterol levels. It has always been this way. While on sabbatical at the University of Oxford, I attended lectures given to medical students on the dietary causes of heart disease by one of their prominent professors of medicine. He went on and on about the adverse effects of saturated fat and cholesterol intakes on coronary heart disease, as if these were the only dietary factors that were important. He was unwilling to concede that animal protein consumption had anything to do with blood cholesterol levels, even though the evidence at that time made it abundantly clear that animal protein was more strongly correlated with blood cholesterol levels than saturated fat and dietary cholesterol. 15. Like too many others, his blind faith in the status quo left him unwilling to be open-minded. As these findings poured in, one was beginning to discover that being open-minded was not a luxury, but a necessity. Fat and breast cancer. If there were some sort of nutrition parade, and each nutrient had a float, by far the biggest would belong to fat. So many people, from researchers to educators, from government policy makers to industry representatives, have investigated or made pronouncements on fat for so long. People from a huge number of different communities have been constructing this behemoth for over half a century. As this strange parade got started on Main Street, USA, the attention of everyone sitting on the sidewalks would inevitably be drawn to the fat float. Most people might see the fat float and say, "I should stay away from that," and then eat a hefty piece of it. Others would climb on the unsaturated half of the float and say that these fats are healthy and only saturated fats are bad. Many scientists would point fingers at the fat float and claim that the heart disease and cancer clowns are hiding inside. Meanwhile, some self-proclaimed diet gurus, like the late Dr. Robert Atkins, might set up shop on the float and start selling books. At the 82 The China Study end of the day, the average person who gorged on the float would be left scratching his head and feeling queasy, wondering what he should have done and why. There's good reason for the average consumer to be confused. The unanswered questions on fat remain unanswered, as they have for the past 40 years. How much fat can we have in our diets? What kind of fat? Is polyunsaturated fat better than saturated fat? Is monounsaturated fat better than either? What about those special fats like omega-3, omega-6, trans fats and DHA? Should we avoid coconut fat? What about fish oil? Is there something special about flaxseed oil? What's a high-fat diet anyway? A low-fat diet? This can be confusing, even for trained scientists. The details that underlie these questions, when considered in isolation, are very misleading. As you shall see, considering how networks of chemicals behave instead of isolated single chemicals is far more meaningful. In some ways, however, it is this foolish mania regarding isolated aspects of fat consumption that teaches us the best lessons. Therefore, let's look a little more closely at this story of fat as it has emerged during the past 40 years. It illustrates why the public is so confused both about fat and about diet in general. On average, we consume 35 to 40% of our total calories as fat. 19 We have been consuming high-fat diets like this since the late 19th century, at the onset of our Industrial Revolution. Because we had more money, we began consuming more meat and dairy, which are relatively high in fat. We were demonstrating our affluence by consuming such foods. Then came the mid to late 20th century when scientists began to question the advisability of consuming diets so high in fat. National and international dietary recommendations to degree B emerged to suggest that we should decrease our fat intake below 30% of calories. That lasted for a couple decades, but now, the fears surrounding high-fat diets are abating. Some authors of popular books even advocate increased fat intake. Some experienced researchers have suggested that it is not necessary to go below 30% fat, as long as we consume the right kind of fat. The level of 30% fat has become a benchmark, even though there is no evidence to suggest that this is a vital threshold. Let's get some perspective on this figure by considering the fat contents of a few foods, as seen in chart 4.6. Lessons from China 83. Chart 4.6, fat content of sample foods. Food percent of calories derived from fat. Butter 100%. McDonald's double cheeseburger 67%. Whole cow's milk 64%. Ham 61%. Hot dog 54%. Soybeans 42%. Low fat, or 2%. Milk 35%. Chicken 26%. Spinach 14%. Wheaties breakfast cereal 8%. Skim milk 5%. Peas 5%. Carrots 4%. Green beans 3.5%. Whole baked potatoes 1%. With a few exceptions, animal-based foods contain considerably more fat than plant-based foods. 24. This is well illustrated by comparing the amount of fat in the diets of different countries. The correlation between fat intake and animal protein intake is more than 90%. 25. This means that fat intake increases in parallel with animal protein intake. In other words, dietary fat is an indicator of how much animal-based food is in the diet. It is almost a perfect match. Fat and a focus on cancer. The 1982 National Academy of Sciences, NAS, report on diet, nutrition, and cancer, of which I was a co-author, was the first expert panel report that deliberated on the association of dietary fat with cancer. This report was the first to recommend a maximum fat intake of 30% of calories for cancer prevention. Previously, the U.S. Senate Select Committee on Nutrition chaired by Senator George McGovern 26 held widely publicized hearings on diet and heart disease and recommended a maximum intake of 30% dietary fat. Although the McGovern Report 84 the HENA study generated a public discourse on diet and disease, it was the 1982 NAS report that gave momentum to this debate. Its focus on cancer, as opposed to heart disease, increased public interest and concern. It spurred additional research activity and public awareness of the importance of diet in disease prevention. Many of the reports at the time 20, 27, 28 were centered on the question of how much dietary fat was appropriate for good health. The unique attention given to fat was motivated by international studies showing that the amount of dietary fat consumed was closely associated with the incidence of breast cancer, large bowel cancer, and heart disease. These were the diseases that kill the majority of people in Western countries before their time. Clearly, this correlation was destined to attract great public attention. The China study was begun in the midst of this environment. The best known study 29 in my view, was that of the late Ken Carroll, professor at the University of Western Ontario in Canada. His findings showed a very impressive relationship between dietary fat and breast cancer, chart 4.7. This finding, which corresponded to the earlier reports of others 3,30, became especially intriguing when compared with migrant studies. 31, 32. These studies showed that people who migrated from one area to another and who started eating the typical diet of their new residency assumed the disease risk of the area to which they moved. This strongly. Chart 4.7, total fat intake and breast cancer. Netherlands. Female. UK, Denmark. Canada. New Zealand. Reland. Switzerland. I.US. Belgium. Australia, Sweden. Austria. Germany. Italy, Norway. France. Czech. Finland, Portugal, Hungary. Hong Kong, Poland. Chile, Bulgaria. Spain. Greece. Philippines, Colombia. Puerto Rico. Mexico, Japan. Taiwan. Ceylon, El Salvador. 20, 40, 60, 80, 100, 120, 140, 160, 180. Total dietary fat intake, G/day. Lessons from China 85. Implied that diet and lifestyle were the principal causes of these diseases. It also suggested that genes are not necessarily that important. As noted earlier, a very prominent report by Sir Richard Dahl and Sir Richard Peto of the University of Oxford, UK, submitted to the US Congress summarized many of these studies and concluded that only 2 to 3% of all cancers could be attributed to genes. 4. Do the data from these international and migrant studies mean that we can lower our rate of breast cancer to almost zero if we make perfect lifestyle choices? The information certainly suggests that this could be the case. Concerning the evidence in chart 4.7, the solution seems obvious. If we eat less fat, then we'll lower our breast cancer risk. Most scientists made this conclusion, and some surmised that dietary fat caused breast cancer. But that interpretation was too simple. Other charts prepared by Professor Carroll were largely, almost totally, ignored. Charts 4.8 and 4.9. They show that breast cancer was associated with animal fat intake but not with plant fat. In rural China, dietary fat intake, at the time of the survey in 1983, was very different from the United States in two ways. First, fat was only 14.5% of calorie intake in China, compared with about 36% in the US. Second, the amount of fat in the diets of rural China depended almost entirely on the amount of animal-based food in the diet, just like the 25. Chart 4.8, animal fat intake and breast cancer. Female. Italy. Portugal. Hong Kong. Netherlands. UK, Denmark. Canada, New Zealand, Switzerland. Belgium, US, Ireland. Germany. Sweden, Australia. Norway. Austria, France, Czech, Hungary, Finland, Bulgaria, Sea Isle, Poland, Venezuela / Romania, Pan Am, Greece, P. Yugoslavia, Philippines, Colombia, Puerto Rico, Japan, Mexico, AYLON, Taiwan, Thailand, El Salvador, O20 40 60 80 100 120 140 160. Animal fat intake, G/day. The HENA study. Chart 4.9, plant fat intake and breast cancer. Female. Netherlands. UK, Denmark. New Zealand, Canada. Ireland, Belgium, ESWITZERLAND. USA. Australia, ESWEDEN. NORWI, Austria, Germany. France, LTALY. Czechoslovakia. FINLANDAHUNGARY. Portugal. Poland, HONGKONGBULGARIA. Chile, EROMANIA. Venezuela. EPANAMA. Puerto Rico, Yugoslavia. Philippines, ECOLOMBIA. TAIWANE, Japan, Mexico. ACAYLON. Thailand, El Salvador. 10 20 30 40. Vegetable fat intake, G/day. 50. ESPAIN. AGREECE. 60 70. Findings in chart 4.7. The correlation between dietary fat and animal protein in rural China was very high, at 70-84%, 33, similar to the 93% seen when comparing different countries. 25. This is important because in China and the international studies, fat consumption was only an indication of animal-based food consumption. Thus, the association between fat and breast cancer might really be telling us that as consumption of animal-based foods goes up, so does breast cancer. This is not the case in the US, where we selectively add or remove fat from our foods and our diets. We get as much or more fat from plant-based food, potato chips, French fries, as we get from processed animal-based foods, skim milk, lean cuts of meat. China does not tinker with fat in their food supply as we do here. At this very low range of dietary fat in China, from 6%-24%, I initially thought that dietary fat would not be linked with diseases like heart disease or the various cancers, as it is in the West. Some people in the U.S., like many of my colleagues in science and medicine, call a 30% fat diet a low-fat diet. Therefore, a low-fat diet containing only lessons from China 87. 25-30% fat was thought to be low enough to obtain the maximum amount of health benefits. This implied that going lower provided no further benefit. Surprise. Findings from rural China showed that reducing dietary fat from 24% to 6% was associated with lower breast cancer risk. However, lower dietary fat in rural China meant less consumption not only of fat but, more importantly, of animal-based food. This connection of breast cancer with dietary fat, thus with animal-based foods, brought into consideration other factors that also place a woman at risk for breast cancer. Early age of menarche, age of first menstruation, high blood cholesterol, late menopause, high exposure to female hormones. What does the China study show regarding these risk factors? Higher dietary fat is associated with higher blood cholesterol, and both of these factors, along with higher female hormone levels, are associated, in turn, with more breast cancer. An earlier age of menarche. The much later age of menarche in rural China is remarkable. 25 women in each of the L30 villages in the survey were asked when they had their first menstrual period. The range of village averages was 15 to 19 years, with an average of 17 years. The U.S. average is roughly 11 years. Many studies have shown that earlier menarche leads to higher risk for breast cancer. 34 Menarche is triggered by the growth rate of the girl. The faster the growth, the earlier the age of onset. It also is well established that rapid growth of young girls often leads to greater adult body height and more body weight and body fatness, each of which is associated with higher breast cancer risk. Early age of menarche, both in Chinese and in Western women, also leads to higher levels of blood hormones such as estrogen. These hormone levels remain high throughout the reproductive years if consumption of a diet rich in animal-based food is maintained. Under these conditions, age of menopause is deferred by 3 to 4 years, thus extending the reproductive life from beginning to end by about 9 to 10 years and greatly increasing lifetime exposure to female hormones. Other studies have shown that an increase in years of reproductive life is associated with increased breast cancer risk. 35-36. This network of relationships becomes still more impressive. Higher. 88 The China study. Fat consumption is associated with higher blood levels of estrogen during the critical years of 35 to 44 years old and higher blood levels of the female hormone prolactin during the later years of 55 to 64 years. These hormones are highly correlated with animal protein intake and milk and meat. Unfortunately, we could not demonstrate whether these hormone levels were directly related to breast cancer risk in China because the rate of disease is so low. 3. Nonetheless, when hormone levels among Chinese women were compared with those of British women, 38 Chinese estrogen levels were only about one-half those of the British women, who have an equivalent hormone profile to that of American women. Because the length of the reproductive life of a Chinese woman is only about 75% of that of the British or American woman, this means that with lower estrogen levels, the Chinese woman only experiences about 35 to 40% of the lifetime estrogen exposure of British and American women. This corresponds to Chinese breast cancer rates that are only 1/5 of those of Western women. The strong association of a high animal protein, high fat diet with reproductive hormones and early age of menarche, both of which raise the risk of breast cancer, is an important observation. It makes clear that we should not have our children consume diets high in animal-based foods. If you are a woman, would you ever have imagined that eating diets higher in animal-based foods would expand your reproductive life by about 9 to 10 years? As an aside, an interesting implication of this observation, as noted by Ms. Magazine founder Gloria Steinem, is that eating the right foods could reduce teenage pregnancy by delaying the age of menarche. Beyond the hormone findings, is there a way to show that animal-based food intake relates to overall cancer rates? This is somewhat difficult, but one of the factors we measured was how much cancer there was in each family. Animal protein intake was convincingly associated in the China study with the prevalence of cancer in families. 3. This association is an impressive and significant observation, considering the unusually low intake of animal protein. Diet and disease factors such as animal protein consumption or breast cancer incidence lead to changes in the concentrations of certain chemicals in our blood. These chemicals are called biomarkers. As an example, blood cholesterol is a biomarker for heart disease. We measured 6 blood biomarkers that are associated with animal protein Intake. 39. Do they confirm the finding that animal protein intake is ASO? Lessons from China. 89. CIA TED with cancer in families. Absolutely. Every single animal protein-related blood biomarker is significantly associated with the amount of cancer in a family. Liam. In this case, multiple observations, tightly networked into a web, show that animal-based foods are strongly linked to breast cancer. What makes this conclusion especially compelling are two kinds of evidence. First, the individual parts of this web were consistently correlated and, in most cases, were statistically significant. Second, this effect occurred at unusually low intakes of animal-based foods. Our investigation of breast cancer, detailed further in Chapter 7, is a perfect example of what makes the China study so convincing. Rather than a single, simple association of fat and breast cancer, we were able to construct a much more expansive web of information about how diet affects breast cancer risk. We were able to examine in multiple ways the role of diet and cholesterol, age of menarche and female hormone levels, all of which are known risk factors for breast cancer. When each new finding pointed in the same direction, we were able to see a picture that was convincing, consistent and biologically plausible. The importance of fiber. The late Professor Dennis Burkitt, of Trinity College, Dublin, was unusually articulate. His common sense, scientific credibility, and sense of humor made quite an impression on me when one first met him at a Cornell seminar. The subject of his work was dietary fiber. He had traveled 10,000 miles in a jeep over rugged countryside to study the dietary habits of Africans. He asserted that even though fiber was not digested, it was vital for good health. Fiber was able to pull water from the body into the intestines to keep things moving along. These undigested fibers, like stick-earned paper, also gather up nasty chemicals that find their way into our intestines, and that might be carcinogenic. If we don't consume enough fiber, we are susceptible to constipation-based diseases. According to Burkitt, these include large bowel cancer, diverticulosis, hemorrhoids, and varicose veins. In 1993, Dr. Burkitt was awarded the prestigious Bauer Award, the richest award in the world next to the Nobel Prize. He invited me to speak at his award ceremony at the Franklin Institute in Philadelphia. Only 2 months before his unfortunate passing, he offered his opinion that our China study was the most significant work on diet and health in the world at that time. 90. The China study. Dietary fiber is exclusively found in plant-based foods. This material, which gives rigidity to the cell walls of plants, comes in thousands of different chemical variations. It is mostly made of highly complex carbohydrate molecules. We digest very little or no fiber. Nonetheless, fiber, having few or no calories itself, helps dilute the caloric density of our diets, creates a sense of fullness and helps to shut down appetite, among other things. In doing so, it satisfies our hunger and minimizes the overconsumption of calories. Average fiber intake, chart 4.low, is about 3 times higher in China than in the US. 40. These differences are exceptional, especially considering the fact that many county averages were even much higher. But according to some experts in the US, there is a dark side to dietary fiber. They contend that if fiber intake is too high, our bodies are not able to absorb as much iron and related minerals, which are essential for health. The fiber may bind with these nutrients and carry them through our system before we are able to digest them. They say that the maximum level of fiber intake should be around 30 to 35 grams per day, which is only about the average intake of the rural Chinese. We studied this iron/fiber issue very carefully in the China study. As it turns out, fiber is not the enemy of iron absorption as so many experts claim it to be. We measured how much iron the Chinese were consuming and how much was in their bodies. Iron was measured in 6 different ways, 4 blood biomarkers and 2 estimates of iron intake, and Chart 4.10, average intakes of dietary fiber, GM/day. 40, 30, 20, 10. Oh. China, United States. Lessons from China 91. When we compared these measurements with fiber intake, there was no evidence showing that increasing fiber intake impaired iron absorption in the body. In fact, we found the opposite effect. A good indicator of how much iron is in the blood, hemoglobin, actually increased with greater intakes of dietary fiber. As it turns out, high fiber foods, like wheat and corn, but not the polished rice consumed in China, also happen to be high in iron, meaning that the higher the consumption of fiber, the higher the consumption of iron. Iron intake in rural China, 34 mg/day, was surprisingly high when compared to the average American intake, 18 milligrams per day, and it was far more associated with plant-based foods than with animal-based foods. Why? The China findings on dietary fiber and iron, like so many other observations in this study, did not support the common view of Western scientists. People who consume more plant-based foods, thus more dietary fiber, also consume more iron, all of which results in statistically significant higher levels of hemoglobin. Unfortunately, a bit of confusion has arisen over the fact that some people in rural China, including women and children, have low iron levels. This is especially true in areas where parasitic diseases are more common. In areas of rural China, where parasitic diseases were more common, iron status was lower. This has given some the opportunity to claim that these people need more meat, but the evidence indicates that the problem would be much better corrected by reducing parasitism in these areas. Much of the initial interest in dietary fiber arose with Burkitt's travels in Africa and his claim that large bowel cancer is lower among populations who consume high fiber diets. Burkitt made this claim popular, but the story is at least 200 years old. In England during the late 18th century and early 19th century, it was claimed by some of the leading physicians that constipation, which was associated with less bulky diets, i.e., low-fiber diets, was associated with a higher risk of cancer, usually breast and intestinal cancers. At the beginning of the China study, this belief that fiber might prevent large bowel cancer was the prevailing view, although the 1982 National Academy of Sciences Committee on Diet, Nutrition, and Cancer found no conclusive evidence to indicate that dietary fiber exerts a protective effect against colorectal cancer in humans. The report went on to conclude, if there is such an effect, specific components of fiber, rather than total dietary fiber, are more likely to be responsible. 20. In hindsight, our discussion of this issue was inadequate. The question 92. The China study. The review of the research literature and the interpretation of the evidence were too focused on looking for a specific fiber as the responsible cause. Finding none, the fiber hypothesis was dismissed. It was a mistake. The China study provided evidence that there is a link with certain cancers. The results showed that high fiber intake was consistently associated with lower rates of cancers of the rectum and colon. High fiber intakes also were associated with lower levels of blood cholesterol, L1I. Of course, high fiber consumption reflected high plant-based food consumption. Foods such as beans, leafy vegetables, and whole grains are all high in fiber. Antioxidants, a beautiful collection. One of the more obvious characteristics of plants is their wide range of bright colors. If you admire how food is presented, it's hard to beat a plate of fruits and vegetables. The reds, greens, yellows, purples and oranges of plant foods are tempting and very healthy. This link between nicely colored vegetables and their exceptional health benefits has often been noted. It turns out that there is a beautiful, scientifically sound story behind this coloral health link. The colors of fruits and vegetables are derived from a variety of chemicals called antioxidants. These chemicals are almost exclusively found in plants. They are only present in animal-based foods to the extent that animals eat them and store a small amount in their own tissues. Living plants illustrate nature's beauty, both in color and in chemistry. They take the energy of the sun and transform it into life through the process of photosynthesis. In this process, the sun's energy is first turned into simple sugars, and then into more complex carbohydrates, fats and proteins. This complex process amounts to some pretty high-powered activity within the plant, all of which is driven by the exchange of electrons between molecules. Electrons are the medium of energy transfer. The site at which photosynthesis takes place is a bit like a nuclear reactor. The electrons zooming around in the plant that are changing the sunlight into chemical energy must be managed very carefully. If they stray from their rightful places in the process, they may create free radicals, which can wreak havoc in the plant. It would be like the core of a nuclear reactor leaking radioactive materials, free radicals, that can be very dangerous to the surrounding area. So how does the plant manage these complex reactions and protect? Lessons from HENA 93. Against errant electrons and free radicals? It puts up a shield around potentially dangerous reactions that sponges up these highly reactive substances. The shield is made up of antioxidants that intercept and scavenge electrons that might otherwise stray from their course. Antioxidants are usually colored because the same chemical property that sponges up excess electrons also creates visible colors. Some of these antioxidants are called carotenoids, of which there are hundreds. They vary in color from the yellow color of beta-carotene, squash, to the red color of lycopene, tomatoes, to the orange color of the odd-sounding cretoxanthins, oranges. Other antioxidants may be colorless, and these include chemicals such as ascorbic acid, vitamin C, and vitamin E, which act as antioxidants in other parts of plants that need to be protected from the hazards of wayward electrons. What makes this remarkable process relevant for us animals, however, is that we produce low levels of free radicals throughout our lifetime. Simply being exposed to the sun's rays, to certain industrial pollutants, and to improperly balanced nutrient intakes creates a background of unwanted free radical damage. Free radicals are nasty. They can cause our tissues to become rigid and limited in their function. It is a bit like old age, when our bodies become creaky and stiff. To a great extent, this is what aging is. This uncontrolled free radical damage also is part of the processes that give rise to cataracts, to hardening of the arteries, to cancer, to emphysema, to arthritis, and many other ailments that become more common with age. But here's the kicker: we do not naturally build shields to protect ourselves against free radicals. As we are not plants, we do not carry out photosynthesis and therefore do not produce any of our own antioxidants. Fortunately, the antioxidants in plants work in our bodies the same way they work in plants. It is a wonderful harmony. The plants make the antioxidant shields, and at the same time make them look incredibly appealing with beautiful, appetizing colors. Then we animals, in turn, are attracted to the plants and eat them and borrow their antioxidant shields for our own health. Whether you believe in God, evolution, or just coincidence, you must admit that this is a beautiful, almost spiritual, example of nature's wisdom. In the China study, we assessed antioxidant status by recording the intakes of vitamin C and beta-carotene and measuring the blood levels of vitamin C, vitamin E, and carotenoids. Among these antioxidant biomarkers, vitamin C provided the most impressive evidence. 94. The China study. The most significant vitamin C association with cancer was its relationship with the number of cancer-prone families in each area. Why? When levels of vitamin C in the blood were low, these families were more likely to have a high incidence of cancer. 3. Low vitamin C was prominently associated with higher risk for esophageal cancer. 4. Leukemia and cancers of the nasopharynx, breast, stomach, liver, rectum, colon, and lung. It was esophageal cancer that first attracted Nova television program producers to report on cancer mortality in China. It was this television program that spurred our own survey to see what was behind this story. Vitamin C primarily comes from fruit, and eating fruit was also inversely associated with esophageal cancer. 243 cancer rates were 5 to 8 times higher for areas where fruit intake was lowest. The same vitamin C effect existing for these cancers also existed for coronary heart disease, hypertensive heart disease, and stroke. Why? Vitamin C intake from fruits clearly showed a powerful protective effect against a variety of diseases. The other measures of antioxidants, blood levels of alpha and beta-carotene, a vitamin precursor, and alpha and gamma tocopherol, vitamin E, are poor indicators of the effects of antioxidants. These antioxidants are transported in the blood by lipoprotein, which is the carrier of bad cholesterol. So anytime we measured these antioxidants, we were simultaneously measuring unhealthy biomarkers. This was an experimental compromise that diminished our ability to detect the beneficial effects of the carotenoids and the tocopherols, even when these benefits are known to exist. 44. We did, however, find that stomach cancer was higher when the blood levels of beta-carotene were lower. 45. Can we say that vitamin C, beta-carotene, and dietary fiber are solely responsible for preventing these cancers? In other words, can a pill containing vitamin C and beta-carotene or a fiber supplement create these health effects? No. The triumph of health lies not in the individual nutrients, but in the whole foods that contain those nutrients, plant-based foods. In a bowl of spinach salad, for example, we have fiber, antioxidants, and countless other nutrients that are orchestrating a wondrous symphony of health as they work in concert within our bodies. The message could not be simpler: eat as many whole fruits, vegetables, and whole grains as you can, and you will probably derive all of the benefits noted above as well as many others. I have been making this point about the health value of whole plant-based foods ever since vitamin supplements were introduced on a large Lessons from China 95 scale in the marketplace. And I have watched in dismay how the industry and the media convinced so many Americans that these products represent the same good nutrition as do whole, plant-based foods. As we shall see in the later chapters, the promised health benefits of taking single nutrient supplements are proving to be highly questionable. The take-home message: if you want vitamin C or beta-carotene, don't reach for the pill bottle, reach for the fruit or leafy green vegetables. The Atkins crisis. In case you haven't noticed, there is an elephant in the room. It goes by the name low-carb diet, and it has become very popular. Almost all diet books on store shelves are variations of this one theme: eat as much protein, meat, and fat as you want, but stay away from those fatty carbs. As you have seen already in this book, my research findings and my point of view show that eating this way is perhaps the single greatest threat to American health we currently face. So what is the story? Anyway, one of the fundamental arguments at the beginning of most low-carbohydrate, high-protein diet books is that America has been wallowing in low-fat mania at the advice of experts for the past 20 years. Yet people are fatter than ever. This argument has an intuitive appeal. But there is one inconvenient fact that is consistently ignored. According to a report 46 summarizing government food statistics, Americans consume 13 pounds, my emphasis, more added fats and oils per person in 1997 than in 1970, up from 52.6 to 65.6 pounds. It is true that we have had a trend to consuming fewer of our total calories as fat, when considered as a percentage, but that's only because we have outpaced our gorging on fat by gorging on sugary junk food. Simply by looking at the numbers, anybody can see that America has not adopted the low-fat experiment, not by any stretch of the imagination. In fact, the claim that the low-fat brainwashing experiment has been tried and failed is often the first of many statements of fact in current diet books that can be described either as severe ignorance or opportunistic deceit. It is difficult to know where to begin to refute the maze of misinformation and false promises commonly made by authors completely untrained in nutrition, authors who have never conducted any peer-reviewed, professionally based experimental research. And yet these books are immensely popular. Why? Because people do lose weight, at least in the short term. 96. The China Study. In one published study 47 funded by the Atkins Center for Complementary Medicine, researchers put 51 obese people on the Atkins diet. 48. The 41 subjects who maintained the diet over the course of 6 months lost an average of 20 pounds. In addition, average blood cholesterol levels decreased slightly 47, which was perhaps even more important. Because of these two results, this study was presented in the media as real, scientific proof that the Atkins diet works and is safe. Unfortunately, the media didn't go much deeper than that. The first sign that all is not rosy is that these obese subjects were severely restricting their calorie intake during the study. The average American consumes about 2,250 calories per day. 49. When the study participants were on the diet, they consumed an average of 1,450 calories per day. That's 35% fewer calories. I don't care if you eat worms and cardboard, if you eat 35% fewer calories, you will lose weight and your cholesterol levels will improve 50 in the short run, but that is not to say that worms and cardboard form a healthy diet. One may argue that those 1,450 calories are so satisfying that people feel full on this diet. But if you compare calorie input and calorie expenditure, it's a matter of simple math that a person cannot sustain this amount of calorie restriction over a period of years or decades without either becoming an invalid or melting away into nothing. People are notoriously unsuccessful at significantly restricting their energy intake over any long period of time, and that is why there has yet to be a long-term study that shows Success with the low-carb diets. This, however, is only the beginning of the problems. In this same study, funded by the Atkins Group, researchers report, at some point during the 24 weeks, 28 subjects, 68%, reported constipation, 63% reported bad breath, 51% reported headache, 10% noted hair loss, and one woman, 1%, reported increased menstrual bleeding. 47 They also refer to other research, saying, adverse effects of this diet in children have included calcium oxalate and urate kidney stones, vomiting, amenorrhea when a girl misses her period, hypercholesterolemia, high cholesterol and vitamin deficiencies, Rev. Cited. 47 Additionally, they found that the dieters had a stunning 53% increase in the amount of calcium they excreted in their urine, 47, which may spell disaster for their bone health. The weight loss, some of which is simply initial fluid 10SS51, may come with a very high price. A different review of low-carbohydrate diets published by Research Lessons from HENA 97 ERS in Australia concludes, complications such as heart arrhythmias, cardiac contractile function impairment, sudden death, osteoporosis, kidney damage, increased cancer risk, impairment of physical activity, and lipid abnormalities can all be linked to long-term restriction of carbohydrates in the diet. 51 One teenage girl recently died suddenly after being on a high-protein diet. 52,53 In short, most people will be unable to maintain this diet for the rest of their lives, and even if anybody manages to do so, they may be asking for serious health problems down the road. I have heard one doctor call high-protein, high-fat, low-carbohydrate diets make yourself sick diets, and I think that's an appropriate moniker. You can also lose weight by undergoing chemotherapy or starting a heroin addiction, but I wouldn't recommend those, either. One final thought, the diet is not all that Atkins recommends. Indeed, most diet books are merely one part of huge food and health empires. In the case of the Atkins diet, Dr. Atkins states that many of his patients require nutrient supplements, some of which are used to combat common dieters' problems. 54 In one passage, after making unsubstantiated claims about the efficacy of antioxidant supplements that contradict recent studies. 55 He writes, add to the antioxidants the phytonutrients known to be useful for each of the myriad medical problems my patients face, and you'll see why many of them take over 30 vitamin pills a day. 56 30 pills a day. There are snake oil salesmen who have no professional research, professional training, or professional publications in the field of nutrition, and there are scientists who have formal training, have conducted research, and have reported on their findings in professional forums. Perhaps it is a testament to the power of modern marketing savvy that an obese man with heart disease and high blood pressure 57 became one of the richest snake oil salesmen ever to live, selling a diet that promises to help you lose weight, to keep your heart healthy, and to normalize your blood pressure. The truth about carbohydrates. An unfortunate outcome of the recent popularity of diet books is that people are more confused than ever about the health value of carbohydrates. As you will see in this book, there is a mountain of scientific evidence to show that the healthiest diet you can possibly consume is a high carbohydrate diet. It has been shown to reverse heart disease, reverse diabetes, prevent a plethora of chronic diseases, and yes, it has. 98 The China study been shown many times to cause significant weight loss. But it's not quite as simple as that. At least 99% of the carbohydrates that we consume are derived from fruits, vegetables, and grains. When these foods are consumed in the unprocessed, unrefined, and natural state, a large proportion of the carbohydrates are in the so-called complex form. This means that they are broken down in a controlled, regulated manner during digestion. This category of carbohydrates includes the many forms of dietary fiber, almost all of which remain undigested but still provide substantial health benefits. In addition, these complex carbohydrates from whole foods are packaged with generous amounts of vitamins, minerals, and accessible energy. Fruits, vegetables, and whole grains are the healthiest foods you can consume, and they are primarily made of carbohydrates. On the opposite side of the spectrum, there are highly processed, highly refined carbohydrates that have been stripped of their fiber, vitamins, and minerals. Typical simple carbohydrates are found in foods like white bread, processed snack items including crackers and chips made with white flour, sweets including pastries and candy bars, and sugar-laden soft drinks. These highly refined carbohydrates originate from grains or sugar plants, like sugar cane or the sugar beet. They are readily broken down during digestion to the simplest form of the carbohydrates, which are absorbed into the body to give blood sugar, or glucose. Unfortunately, most Americans consume voluminous amounts of simple, refined carbohydrates and paltry amounts of complex carbohydrates. For example, in 1996, 42% of Americans ate cakes, cookies, pastries, or pies on any given day, while only 10% ate any dark green vegetables. 46 in another ominous sign, only 3 vegetables accounted for half of the total vegetable servings in 199,646 potatoes, which were mostly consumed as fries and chips, had lettuce, one of the least nutrient-dense vegetables you can consume, and canned tomatoes, which is probably only a reflection of pizza and pasta consumption. Add to that the fact that the average American consumed 32 teaspoons of added sugars per day in 1996,46, and it's clear that Americans are gorging almost exclusively on refined, simple carbohydrates, at the exclusion of healthful complex carbohydrates. This is bad news, and this, in large measure, is why carbohydrates as a whole have gotten such a bad rap. The vast majority of carbohydrates consumed in America are found in junk food or grains so refined that they have to be supplemented with vitamins and minerals. On this, Lessons from China 99. Point, the popular diet authors and I agree. For example, you could eat a low-fat, high-carbohydrate diet by exclusively eating the following foods: pasta made from refined flour, baked potato chips, soda, sugary cereals, and low-fat candy bars. Eating this way is a bad idea. You will not derive the health benefits of a plant-based diet eating these foods. In experimental research, the health benefits of a high-carbohydrate diet come from eating the complex carbohydrates found in whole grains, fruits, and vegetables. Eat an apple, a zucchini, or a plate of brown rice, topped with beans and other vegetables. The China study weighs in. With regard to weight loss, there are some surprising findings from the China study that shed light on the weight loss debate. When we started the China study, I thought that China had the opposite problem from that of the US. I had heard that China could not feed itself, that it was prone to famines, and that there was not enough food for people to attain their full adult height. Very simply, there were not enough calories to go around. Although China has, during the last 50 years, had its share of nutritional problems, we were to learn that these views on calorie intake were dead wrong. We wanted to compare the calorie consumption in China and America, but there was a catch. Chinese are more physically active than Americans, especially in rural areas, where manual labor is the norm. 2. Compare an extremely active laborer with an average American would be misleading. It would be like comparing the amount of energy consumed by a manual laborer at hard work with the amount of energy consumed by an accountant. The vast difference in calorie intake sure to exist between these individuals would tell us nothing of value and only confirm that the manual laborer is more active. To overcome this problem, we rank the Chinese into 5 groups, according to their levels of physical activity. After figuring out the calorie intakes of the least active Chinese, the equivalent of office workers, we then compared their calorie intake with the average American. What we found was astonishing. Average calorie intake, per kilogram of body weight, was 30% higher among the least active Chinese than among average Americans. Yet, body weight was 20% lower, chart 4.11. How can it be that even the least active Chinese consume more calories yet have no overweight problems? What is their secret? 100. The China study. Chart 4.11, calorie consumption, kcal/kg. And body weight. Calorie intake, kcal/kg. China US. Average body mass index. 30. 25. 20. 15. 10. China US. There are 2 possible explanations for this apparent paradox. First, even the Chinese office workers are more physically active than average Americans. Anyone familiar with China knows that many office workers travel on bicycles. Thus, they consume more calories. Even so, we cannot tell how much of the extra calorie consumption was due to physical activity and how much to something else, perhaps their food. We do know, however, that some people use the calories they consume differently from other people. We often say that they have a higher rate of metabolism or it's in their genes. You know these people. They are the ones who seem to eat all they want and still not gain weight. Then there are most of us, who need to watch our calorie intake, or so we think. This is the simplistic interpretation. I have a more comprehensive interpretation that is based on our own considerable research and on the studies of others. It goes like this. Provided that we aren't restricting our calorie intake, those of us who consume a high-fat, high-protein diet simply retain more calories than we need. We store these calories as body fat, perhaps weave it into our muscle fibers, we call it marbling in beef animals, and perhaps store it in the more obvious places, like our butt, our midsection, or around our face and upper thighs. Here's the clincher, only a small amount of calories needs to be retained by our body to cause significant change in body weight. For example, if we retain only an extra 50 calories per day, this can lead to an extra 10 pounds per year. You may not think that this is a lot, but over a period of 5 years, that's an extra 50 pounds. Some people would hear this and might be inclined to just eat 50 fewer calories per day. This, theoretically, could make a difference, but it Lessons from China 101 is entirely impractical. It is impossible to keep track of daily calorie intake with such precision. Think about eating a meal at a restaurant. Do you know how many calories each meal has? What about the casserole? You might fix What about the steak you might buy? Do you know the number of calories they contain? Of course not. The truth is this: despite any short-term caloric restriction regimes we may follow, our body, through many mechanisms, will ultimately choose how many calories to take in and what to do with them. Our attempts to limit calorie intake is short-lived and imprecise, whether we do it by limiting carbohydrates or fat. The body employs a delicate balancing act and some very intricate mechanisms in deciding how to use the calories being consumed. When we treat our body well by eating the right foods, it knows how to partition the calories away from body fat and into the more desirable functions like keeping the body warm, running the body metabolism, supporting and encouraging physical activity, or just disposing of any excess. The body is using multiple intricate mechanisms to decide how calories get used, stored, or burned off. Consuming diets high in protein and fat transfers calories away from their conversion into body heat to their storage form as body fat. And less severe calorie restriction is causing weight loss. In contrast, diets low in protein and fat cause calories to be lost as body heat. In research, we say that storing more calories as fat and losing less as heat means being more efficient. I bet that you would rather be a little more inefficient and convert it into body heat rather than body fat, right? Well, simply consuming a diet lower in fat and protein can do this. This is what our China study data show. Chinese consume more calories both because they are more physically active and because their consumption of low-fat, low-protein diets shifts conversion of these calories away from body fat to body heat. This is true even for the least physically active Chinese. Remember, it takes very little, only 50 calories a day, to change our storage of body fat and thus change our body weight. 58. We saw the same phenomenon in our experimental animals fed the low-protein diets. They routinely consumed slightly more calories, gained less weight, disposed of the extra calories as body heat 59, and voluntarily exercised more 60 while still having far less cancer than animals. On standard diets, we found that calories were burned at a faster rate and transformed into body heat as more oxygen was consumed. 59. 102. The China study. Understanding that diet can cause small shifts in calorie metabolism that lead to big shifts in body weight is an important and useful concept. It means that there is an orderly process of controlling body weight over time that does work, as opposed to the disorderly process of crash diets that don't work. It also accounts for the frequent observations, discussed in Chapter 6, that people who consume low-protein, low-fat diets composed of whole plant foods have far less difficulty with weight problems, even if they consume the same, or even slightly more, total calories, diet, and body size. We now know that eating a low-fat, low-protein diet high in complex carbohydrates from fruits and vegetables will help you lose weight. But what if you want to become bigger? A desire to be as big as possible is pervasive in most cultures. During the colonial period in Asia and Africa, Europeans even considered smaller people to be less civilized. Body size seems to be a mark of prowess, manliness, and dominance. Most people think they can be bigger and stronger by eating protein-rich animal-based foods. This belief stems from the idea that consuming protein, aka meat, is needed for physical power. This has been a common notion the world over for a long time. The Chinese have even officially recommended a higher protein diet in order to encourage bigger athletes and to better compete in the Olympics. Animal-based foods have more protein, and this protein is considered to be of higher quality. Animal protein enjoys the same reputation in a rapidly modernizing China as everywhere else. There is, however, a problem with the idea that consuming animal-based foods is a good way of becoming bigger. The people who eat the most animal protein have the most heart disease, cancer, and diabetes. In the China study, for example, animal protein consumption was associated with taller and heavier people, but was also associated with higher levels of total and bad cholesterol. Why furthermore, body weight, associated with animal protein intake, was associated with more cancer and more coronary heart disease. Why it seems that being bigger, and presumably better, comes with very high costs. But might it be possible for us to achieve our full growth potential, while simultaneously minimizing disease risks? Childhood growth rates were not measured in the China study, but adult height and weight were. This information proved surprising. Consuming more protein was associated with greater body size. 3-4. Lessons from China 103. Men and 11 for women. 0.6 However, this effect was primarily attributed to plant protein, because it makes up 90% of the total Chinese protein intake. Animal protein consumption was indeed associated with greater body weight and consumption of protein-rich milk seemed to be effective as well. 1. But the good news is this: greater plant protein intake was closely linked to greater height and body weight. Body growth is linked to protein in general, and both animal and plant proteins are effective. This means that individuals can achieve their genetic potential for growth and body size by consuming a plant-based diet. So why is it that people in developing nations, who consume little or no animal-based foods, are consistently smaller than Western people? This is because plant-based diets in poor areas of the world usually have insufficient variety, inadequate quantity and quality, and are associated with poor public health conditions where childhood diseases are prevalent. Under these conditions, growth is stunted and people do not reach their genetic potential for adult body size. In the China study, low adult height and weight were strongly associated with areas having high mortality rates for pulmonary tuberculosis, parasitic diseases, gill pneumonia, ill for height, intestinal obstruction, and digestive diseases. 3. These findings support the idea that body stature can be achieved by consuming a low-fat, plant-based diet, provided that public health conditions effectively control the diseases of poverty. Under these conditions, the diseases of affluence, heart disease, cancers, diabetes, etc., can be simultaneously minimized. The same low animal protein, low-fat diet that helps prevent obesity also allows people to reach their full growth potential while working other wonders as well. It better regulates blood cholesterol and reduces heart disease and a variety of cancers. What are the odds that all of these associations, and many others, favoring a plant-based diet are due to pure chance? It is extremely unlikely, to say the least. Such consistency of evidence across a broad range of associations is rare in scientific research. It points to a new worldview, a new paradigm. It defies the status quo, promises new health benefits, and demands our attention. 104. The China study. Circling back, in the beginning of my career, I concentrated on the biochemical processes of liver cancer. Chapter 3 delineates the decades-long laboratory work we did with experimental animals, work that passed the requirements to be called good science. The finding, casein, and very likely all animal proteins, may be the most relevant cancer-causing substances that we consume. Adjusting the amount of dietary casein has the power to turn on and turn off cancer growth, and to override the cancer-producing effects of aflatoxin, a very potent class IA carcinogen. But even though these findings were substantially confirmed, they still applied to experimental animals. It was therefore with great anticipation that I looked to the China study for evidence on the causes of liver cancer in humans. 62. Liver cancer rates are very high in rural China, exceptionally high in some areas. Why was this? The primary culprit seemed to be chronic infection with hepatitis B virus, HBV. On average, about 12 to 13% of our study subjects were chronically infected with the virus. In some areas, 1/2 of the people were chronically infected. To put this into perspective, only 0.2 to 0.3% of Americans are chronically infected with this virus. But there's more. In addition to the virus being a cause of liver cancer, in China, it seems that diet also plays a key role. How do we know? The blood cholesterol levels provided the main clue. Liver cancer is strongly associated with increasing blood cholesterol 3, and we already know that animal-based foods are responsible for increases in cholesterol. So, where does HBV fit in? The experimental mice studies gave a good signal. In mice, HBV initiated the liver cancer, but the cancer grew in response to the feeding of higher levels of casein. In addition, blood cholesterol also increased. These observations fit perfectly with our human findings. Individuals who are chronically infected with HBV and who consume animal-based foods have high blood cholesterol and a high rate of liver cancer. The virus provides the gun, and bad nutrition pulls the trigger. A very exciting story was taking shape, at least to my way of thinking. It was a story full of meaning and suggestive of important principles that might apply to other diet and cancer associations. It also was a story that had not been told to the public, and yet it was capable of saving lives. Eventually, it was a story that was leading to the idea that our most powerful weapon against cancer is the food we eat every day. Lessons from China 105. So there we had it. The years of animal experiments illuminated profound biochemical principles and processes that greatly helped to explain the effect of nutrition on liver cancer. But now we could see that these processes were relevant for humans as well. People chronically infected with hepatitis B virus also had an increased risk of liver cancer. But our findings suggested those who were infected with the virus and who were simultaneously eating more animal-based foods had higher cholesterol levels and more liver cancer than those infected with the virus and not consuming animal-based foods. The experimental animal studies and the human studies made a perfect fit. Pulling it together, almost all of us in the United States will die of diseases of affluence. In our China study, we saw that nutrition has a very strong effect on these diseases. Plant-based foods are linked to lower blood cholesterol, animal-based foods are linked to higher blood cholesterol. Animal-based foods are linked to higher breast cancer rates, plant-based foods are linked to lower rates. Fiber and antioxidants from plants are linked to a lower risk of cancers of the digestive tract. Plant-based diets and active lifestyles result in a healthy weight, yet permit people to become big and strong. Our study was comprehensive in design and comprehensive in its findings. From the labs of Virginia Tech and Cornell University to the far reaches of China, it seemed that science was painting a clear, consistent picture. We can minimize our risk of contracting deadly diseases. just by eating the right food. When we first started this project, we encountered significant resistance from some people. One of my colleagues at Cornell, who had been involved in the early planning of the China study, got quite heated in one of our meetings. I had put forth the idea of investigating how lots of dietary factors, some known but many unknown, work together to cause disease. Thus we had to measure lots of factors, regardless of whether or not they were justified by prior research. If that was what we intended to do, he said he wanted nothing to do with such a shotgun approach. This colleague was expressing a view that was more in line with mainstream scientific thought than with my idea. He and like-minded colleagues think that science is best done when investigating single mostly known factors in isolation. An array of largely unspecified factors doesn't show anything, they say. It's okay to measure the specific effect of, say, selenium on breast cancer, but it's not okay to measure 106 the China study. Multiple nutritional conditions in the same study, in the hope of identifying important dietary patterns. I prefer the broader picture, for we are investigating the incredible complexities and subtleties of nature itself. I wanted to investigate how dietary patterns related to disease, now the most important point of this book. Everything in food works together to create health or disease. The more we think that a single chemical characterizes a whole food, the more we stray into idiocy. As we shall see in part 4 of this book, this way of thinking has generated a lot of poor science. So I say we need more, not less, of the shotgun approach. We need more thought about overall dietary patterns and whole foods. Does this mean that I think the shotgun approach is the only way to do research? Of course not. Do I think that the China study findings constitute absolute scientific proof? Of course not. Does it provide enough information to inform some practical decision making? Absolutely. An impressive and informative web of information was emerging from this study. But does every potential strand, or association, in this mammoth study fit perfectly into this web of information? No. Although most statistically significant strands readily fit into the web, there were a few surprises. Most, but not all, have since been explained. Some associations observed in the China study, at first glance, were at odds with what might have been expected from Western experience. I've had to use care in separating unusual findings that could be due to chance and experimental insufficiency from those that truly offered new insights into our old ways of thinking. As I mentioned earlier, the range of blood cholesterol levels in rural China was a surprise. At the time when the China study was begun, a blood cholesterol range of 200 to 300 milligrams per deciliter, mg/LDL, was considered normal, and lower levels were suspect. In fact, some in the scientific and medical communities considered cholesterol levels lower than 150 mg/LDL to be dangerous. In fact, my own cholesterol was 260 mg/LDL in the late 1970s. Not unlike other members of my immediate family. The doctor told me it was fine, just average. But when we measured the blood cholesterol levels in China, we were shocked. They ranged from 70 to 170 mg/LDL. Their high was our low, and their low was off the chart you might find in your doctor's office. It became obvious that our idea of normal values, or ranges, only applies to Western subjects consuming the Western diet. It so happens, for example, that our normal cholesterol levels present a lessons from China 107 significant risk for heart disease. Sadly, it's also normal to have heart disease in America. Over the years, standards have been established that are consistent with what we see in the West. We too often have come to the view that US values are normal because we have a tendency to believe that the Western experience is likely to be right. At the end of the day, the strength and consistency of the majority of the evidence is enough to draw valid conclusions. Namely, whole plant-based foods are beneficial, and animal-based foods are not. Few other dietary choices, if any, can offer the incredible benefits of looking good, growing tall, and avoiding the vast majority or premature diseases. In our culture, the China study was an important milestone in my thinking. Standing alone, it does not prove that diet causes disease. Absolute proof in science is nearly unattainable. Instead, a theory is proposed and debated until the weight of the evidence is so overwhelming that everyone commonly accepts that the theory is most likely true. In the case of diet and disease, the China study adds a lot of weight to the evidence. Its experimental features, multiple diet, disease, and lifestyle characteristics, an unusual range of dietary experience, a good means of measuring data quality, provided an unparalleled opportunity to expand our thinking about diet and disease in ways that previously were not available. It was a study that was like a flashlight that illuminated a path that I had never fully seen before. The results of this study, in addition to a mountain of supporting research, some of it my own and some of it from other scientists, convinced me to turn my dietary lifestyle around. I stopped eating meat 15 years ago, and I stopped eating almost all animal-based foods, including dairy, within the past 6 to 8 years, except on very rare occasions. My cholesterol has dropped, even as I've aged. I am more physically fit now than when I was 25, and I am 45 pounds lighter now than I was when I was 30 years old. I am now at an ideal weight for my height. My family has also adopted this way of eating, thanks in large part to my wife Karen, who has managed to create an entire new dietary lifestyle that is attractive, tasty, and healthy. This has all been done for health reasons, the result of my research findings, telling me to wake up from a boyhood of drinking at least 2 quarts of milk a day to an early professional career of scoffing at vegetarians. I have taken an unusual turn in my life. However, it has been more than my own research that has changed my life. Over the years, I have gone well beyond our own research find. 108 The China study aims to see what other researchers have found regarding diet and health. As our research findings expanded from the specific to the general, the picture has continued to enlarge. We now can look at the work of other scientists to put my findings into a larger context. As you shall see, it is nothing short of astonishing. Diseases of affluence. Here in America, we are affluent, and we die certain deaths because of it. We eat like feasting kings and queens every day of the week, and it kills us. You probably know people who suffer from heart disease, cancer, stroke, Alzheimer's, obesity, or diabetes. There's a good chance that you yourself suffer from one of these problems, or that one of these diseases runs in your family. As we have seen, these diseases are relatively unknown in traditional cultures that subsist mostly on whole plant foods, as in rural China. But these ailments arrive when a traditional culture starts accumulating wealth and starts eating more and more meat, dairy, and refined plant products, like crackers, cookies and soda. In public lectures, I start my presentation by telling the audience my personal story, just as I have done in this book. Invariably, I get a question at the end of the lecture from someone who wants to know more about diet and a specific disease of affluence. Chances are that you yourself also have a question about a specific disease. Chances are, too, that this specific disease is a disease of affluence, because that's what we die of here in America. You might be surprised to know that the disease that interests you has much in common with other diseases of affluence, especially when it comes to nutrition. There is no such thing as a special diet for cancer, and a different, equally special diet for heart disease. The evidence now amassed from researchers around the world shows that the same diet that is good for the prevention of cancer is also good for the prevention. 109. 110. The China study of heart disease, as well as obesity, diabetes, cataracts, macular degeneration, Alzheimer's, cognitive dysfunction, multiple sclerosis, osteoporosis and other diseases. Furthermore, this diet can only benefit everyone, regardless of his or her genes or personal dispositions. All of these diseases, and others, spring forth from the same influence, an unhealthy, largely toxic diet and lifestyle that has an excess of sickness-promoting factors and a deficiency of health-promoting factors. In other words, the Western diet. Conversely, there is one diet to counteract all of these diseases, a whole foods, plant-based diet. The following chapters are organized by disease, or disease grouping. Each chapter contains evidence showing how food relates to each disease. As you go through each chapter, you will begin to see the breadth and depth of the astonishing scientific argument favoring a whole foods, plant-based diet. For me, the consistency of evidence regarding such a disparate group of diseases has been the most convincing aspect of this argument. When a whole foods, plant-based diet is demonstrably beneficial for such a wide variety of diseases, is it possible that humans were meant to consume any other diet? I say no, and I think you'll agree. America and most other Western nations have gotten it wrong when it comes to diet and health, and we have paid a grave price. We are sick, overweight and confused. As I have moved on from the laboratory studies and the China study and encountered the information discussed in Part 2, I have become overwhelmed. I have come to realize that some of our most revered conventions are wrong and real health has been grossly obscured. Most unfortunately, the unsuspecting public has paid the ultimate price. In large measure, this book is my effort to right these wrongs. As you will come to see in the following chapters, from heart disease to cancer, and from obesity to blindness, there is a better path to optimal health. Broken hearts. Put your hand on your chest and feel your heartbeat. Now put your hand where you can feel your pulse. That pulse is the signature of your being. Your heart, creating that pulse, is working for you every minute of the day, every day of the year, and every year of your entire life. If you live an average lifetime, your heart will beat about 3 billion times. L. Now take a moment to realize that during the time it took you to read the above paragraph, an artery in the heart of roughly one American clogged up, cut off blood flow and started a rapid process of tissue and cell death. This process is better known, of course, as a heart attack. By the time you finish reading this page, 4 Americans will have had a heart attack, and another 4 will have fallen prey to stroke or heart failure. 2. Over the next 24 hours, 3,000 Americans will have heart attacks, to roughly the same number of people who perished in the terrorist attacks of September 11, 200L. The heart is the centerpiece of life and, more often than not in America, it is the centerpiece of death. Malfunction of the heart and / or circulation system will kill 40% of Americans, 3 more than those killed by any other injury or ailment, including cancer. Heart disease has been our number 1 cause of death for almost 100 years. For this disease does not recognize gender or race boundaries, all are affected. If you were to ask most women what disease poses the greatest risk to them, heart disease or breast cancer, many women would undoubtedly say breast cancer. But they would be wrong. Women's death rate from heart disease is 8 times higher than their death rate from breast cancer. 5. 112. The China study. If there is an American game, it is baseball, an American dessert, apple pie. If there is an American disease, it is heart disease. Everyone's doing it. In 1950, Judy Holliday could be seen on the big screen. Ben Hogan dominated the world of golf. The musical South Pacific won big at the Tony Awards, and on June 25th, North Korea invaded South Korea. The American administration was taken aback but responded quickly. Within days, President Truman sent in troops on the ground and bombers overhead to push back the North Korean army. 3 years later, in July of 1953, a formal ceasefire agreement had been signed and the Korean War was over. During this period of time, over 30,000 American soldiers were killed in battle. At the end of the war, a landmark scientific study was reported in the Journal of the American Medical Association. Military medical investigators had examined the hearts of 300 male soldiers killed in action in Korea. The soldiers, at an average age of 22 years, had never been diagnosed with heart problems. In dissecting these hearts, researchers found startling evidence of disease in an exceptional number of cases. Fully 77.3% of the hearts they examined had gross evidence of heart disease. In this instance, gross means large. That number, 77.3%, is startling. Coming at a time when our number 1 killer was still shrouded in mystery, the research clearly demonstrated that heart disease develops over an entire lifetime. Furthermore, almost everyone was susceptible. These soldiers were not couch potato slouches, they were in top condition in the prime of their physical lives. Since that time, several other studies have confirmed that heart disease is pervasive in young Americans. The heart attack. But what is heart disease? One of the key components is plaque. Plaque is a greasy layer of proteins, fats, including cholesterol, immune system cells and other components that accumulate on the inner walls of the coronary arteries. I have heard one surgeon say that if you wipe your finger on a plaque-covered artery, it has the same feel as wiping your finger across a warm cheesecake. If you have plaque building up in your coronary arteries, you have some degree of heart disease. Of the autopsied soldiers in Korea, 1 out of 20 diseased men had so much plaque that 90% of an artery was blocked. That's like putting a broken heart's 113 kink in a garden hose and watering a desperately dry garden with the resulting trickle of water. Why hadn't these soldiers had a heart attack already? After all, only 10% of the artery was open. How could that be enough? It turns out that if the plaque on the inner wall of the artery accumulates slowly over several years, blood flow has time to adjust. Think of blood flowing through your artery as a raging river. If you put a few stones on the sides of a river every day over a period of years, like plaque accumulating on the walls of the artery, the water will find another way to get to where it wants to be. Maybe the river will form several smaller streams over the stones. Perhaps the river will go under the stones, forming tiny tunnels. Or maybe the water will flow through small side streams, taking a new route altogether. These new tiny passageways around or through the stones are called collaterals. The same thing happens in the heart. If plaque accumulates over a period of several years, there will be enough collateral development that blood can still travel throughout the heart. However, too much plaque buildup can cause severe blood restriction, and debilitating chest pain, or angina, can result. But this buildup only rarely leads to heart attacks. 9. 10. So what leads to heart attacks? It turns out that it's the less severe accumulations of plaque, blocking under 50% of the artery, that often cause heart attacks. These accumulations each have a layer of cells, called the cap, which separates the core of the plaque from the blood flowing by. In the dangerous plagues, the cap is weak and thin. Consequently, as blood rushes by, it can erode the cap until it ruptures. When the cap ruptures, the core contents of the plaque mix with the blood. The blood then begins clotting around the site of rupture. The clot grows and can quickly block off the entire artery. When the artery becomes blocked over such a short period of time, there is little chance for collateral blood flow to develop. When this happens, blood flow downstream of the rupture is severely reduced and the heart muscles don't get the oxygen they require. At this point, as heart muscle cells start to die, heart pumping mechanisms begin to fail, and the person may feel a crushing pain in the chest, or a searing pain down into an arm and up into the neck and jaw. In short, the victim starts to die. This is the process behind most of the 1 million heart attacks that occur in America every year. 1 out of 3 people who have a heart attack will die from it. 9. 10. We now know that the small to medium accumulation of plaque, the plaque that blocks less than 50% of the artery, is the most deadly. 2. 12. 114. The China study. So how can we predict the timing of heart attacks? Unfortunately, with existing technologies, we can't. We can't know which plaque will rupture, when, or how severe it might be. What we do know, however, is our relative risk for having a heart attack. What once was a mysterious death, which claimed people in their most productive years, has been demystified by science. No study has been more influential than that of the Framingham Heart Study. Framingham. After World War II, the National Heart Institute L3 was created with a modest budget for and a difficult mission. Scientists knew that the greasy plagues that lined the arteries of diseased hearts were composed of cholesterol, phospholipids, and fatty acids, 14, but they didn't know why these lesions developed, how they developed, or exactly how they led to heart attacks. In the search for answers, the National Heart Institute decided to follow a population over several years, to keep detailed medical records of everybody in the population and to see who got heart disease and who didn't. The scientists headed to Framingham, Massachusetts. Located just outside of Boston, Framingham is steeped in American history. European settlers first inhabited the land in the 17th century. Over the years, the town has had supporting roles in the Revolutionary War, the Salem witch trials and the abolition movement. More recently, in 1948, the town assumed its most famous role. Over 5,000 residents of Framingham, both male and female, agreed to be poked and prodded by scientists over the years so that we might learn something about heart disease. And learn something we did by watching who got heart disease and who didn't, and comparing their medical records. The Framingham Heart Study developed the concept of risk factors such as cholesterol, blood pressure, physical activity, cigarette smoking, and obesity. Because of the Framingham study, we now know that these risk factors play a prominent role in the causation of heart disease. Doctors have for years used a Framingham prediction model to tell who is at high risk for heart disease and who is not. Over 1,000 scientific papers have been published from this study, and the study continues to this day, having now studied 4 generations of Framingham residents. The shining jewel of the Framingham study is its findings on blood cholesterol. In 1961, they convincingly showed a strong correlation between high blood cholesterol and heart disease. Researchers noted that broken hearts 115 men with cholesterol levels over 244 mg/LDL, milligrams per deciliter, have more than 3 times the incidence of CHD, coronary heart disease, as do those with cholesterol levels less than 210 mg/LDL. 15. The contentious question of whether blood cholesterol levels could predict heart disease was laid to rest. Cholesterol levels do make a difference. In this same paper, high blood pressure was also demonstrated to be an important risk factor for heart disease. The importance given to risk factors signaled a conceptual revolution. When this study was started, most doctors believed that heart disease was an inevitable wearing down of the body, and we could do little about it. Our hearts were like car engines. As we got older, the parts didn't work as well and sometimes gave out. By demonstrating that we could see the disease in advance by measuring risk factors, the idea of preventing heart disease suddenly had validity. Researchers wrote, "It appears that a preventive program is clearly necessary." 15. Simply lower the risk factors, such as blood cholesterol and blood pressure, and you lower the risk of heart disease. In modern-day America, cholesterol and blood pressure are household terms. We spend over $30 billion a year on drugs to control these risk factors and other aspects of cardiovascular disease. 2. Almost everyone now knows that he or she can work to prevent a heart attack by keeping his or her risk factors at the right levels. This awareness is only about 50 years old and due in large measure to the scientists and subjects of the Framingham Heart Study. Outside our borders, Framingham is the most well-known heart study ever done, but it is merely one part of an enormous body of research conducted in this country over the past 60 years. Early research led to the alarming conclusion that we have some of the highest rates of heart disease in the world. One study published in 1959 compared the coronary heart disease death rates in 20 different countries, chart 5.1.16. These studies were examining westernized societies. If we look at more traditional societies, we tend to see even more striking disparities in the incidence of heart disease. The Papua New Guinea Highlanders, for example, pop up in research quite a bit because heart disease is rare in their society. Why? Remember, for example, how low the rate of heart disease was in rural China. American men died from heart disease at a rate almost 17 times higher than their Chinese counterparts. IS 116. The China Study, chart 5.1, Heart disease death rates for men aged 55 to 59. Across 20 countries, circa 195,516. Why were we succumbing to heart disease in the 60s and 70s, when much of the world was relatively unaffected? Quite simply, it was a case of death by food. The cultures that have lower heart disease rates eat less saturated fat and animal protein and more whole grains, fruits, and vegetables. In other words, they subsist mostly on plant foods while we subsist mostly on animal foods. But might it be that the genetics of one group might just make them more susceptible to heart disease? We know that this is not the case, because within a group with the same genetic heritage, a similar relationship between diet and disease is seen. For example, Japanese men who live in Hawaii or California have a much higher blood cholesterol level and incidence of coronary heart disease than Japanese men living in Japan. 1920. The cause is clearly environmental, as most of these people have the same genetic heritage. Smoking habits are not the cause because men broken hearts 117. In Japan, who were more likely to smoke, still had less coronary heart disease than the Japanese Americans. 19. The researchers pointed to diet, writing that blood cholesterol increased with dietary intake of saturated fat, animal protein and dietary cholesterol. On the flip side, blood cholesterol was negatively associated with complex carbohydrate intake. 20. In simple terms, animal foods were linked to higher blood cholesterol, plant foods were linked to lower blood cholesterol. This research clearly implicated diet as one possible cause of heart disease. Furthermore, the early results were painting a consistent picture: the more saturated fat and cholesterol, as indicators of animal food consumption, people eat, the higher their risk for getting heart disease. And as other cultures have come to eat more like us, they also have seen their rates of heart disease skyrocket. In more recent times, several countries have now come to have a higher death rate from heart disease than America. Research ahead of its time. So now we know what heart disease is and what factors determine our risk for it, but what do we do once the disease is upon us? When the Framingham Heart Study was just beginning, there were already doctors who were trying to figure out how to treat heart disease, rather than just prevent it. In many ways, these investigators were ahead of their time because their interventions, which were the most innovative, successful treatment programs at the time, utilized the least advanced technology available, the knife and fork. These doctors noticed the ongoing research at the time and made some common sense connections. They realized that 2L excess fat and cholesterol consumption caused atherosclerosis, the hardening of the arteries and the accumulation of plaque, in experimental animals. Eating cholesterol in food caused a rise in cholesterol in the blood. High blood cholesterol might predict and/or cause heart disease. Most of the world's population didn't have heart disease, and these heart disease-free cultures had radically different dietary patterns, consuming less fat and cholesterol. So they decided to try to alter heart disease in their patients by having them eat less fat and cholesterol. One of the most progressive doctors was Dr. Lester Morrison of Los 118. The HENA study. Angeles. He started a study in 1946, 2 years before the Framingham study, to determine the relationship of dietary fat intake to the incidence of atherosclerosis. 22. In his study, he instructed 50 heart attack survivors to maintain their normal diet and 50 different heart attack survivors to consume an experimental diet. In the experimental diet group, he reduced the consumption of fat and cholesterol. One of his published sample menus allowed the patient to have only a small amount of meat 2 times a day, 2 ounces of cold roast lamb, lean, with mint jelly for lunch, and another 2 ounces of lean meats for dinner. 22 Even if you loved cold roast lamb with mint jelly, you weren't allowed to eat much of it. In fact, the list of prohibited foods in the experimental diet was fairly long and included cream soups, pork, fat meats, animal fats, whole milk, cream, butter, egg yolks and breads and desserts made with butter, whole eggs and whole milk. 22. Did this progressive diet accomplish anything? After 8 years, only 12 of 50 people eating their normal American diet were alive. 24%. In the diet group, 28 people were still alive, 56%. Almost 2.5 times the amount of survivors in the control group. After 12 years, every single patient in the control group was dead. In the diet group, however, 19 people were still alive, a survival rate of 38%. 22 While it was unfortunate that so many people in the dietary group still died, it was clear that they were staving off their disease by eating moderately less animal foods and moderately more plant foods. See Chart 5.2. Chart 5.2, Survival Rate of Dr. Morrison's Patients. Broken Hearts 119. In 1946, when this study began, most scientists believed that heart disease was an inevitable part of aging, and nothing much could be done about it. While Morrison didn't cure heart disease, he proved that something as simple as diet could significantly alter its course, even when the disease is so advanced that it has already caused a heart attack. Another research group proved much the same thing at about that time. A group of doctors in Northern California took a larger group of patients with advanced heart disease and put them on a low-fat, low-cholesterol diet. These doctors found that the patients who ate the low-fat, low-cholesterol diet died at a rate 4 times lower than patients who didn't follow the diet. 23. It was now clear that there was hope. Heart disease wasn't the inevitable result of old age, and even when a person had advanced disease, a low-fat, low-cholesterol diet could significantly prolong his or her life. This was a remarkable advance in our understanding of the number 1 killer in America. Furthermore, this new understanding made diet and other environmental factors the centerpieces of heart disease. Any discussion of diet, however, was narrowly focused on fat and cholesterol. These 2 isolated food components became the bad guys. We now know that the attention paid to fat and cholesterol was misguided. The possibility that no one wanted to consider was that fat and cholesterol were merely indicators of animal food intake. For example, look at the relationship between animal protein consumption and heart disease death in men aged 55 to 59 across 20 different countries in Chart 5.3. 16. This study suggests that the more animal protein you eat, the more heart disease you have. In addition, dozens of experimental studies show that feeding rats, rabbits and pigs animal protein, example casein, dramatically raises cholesterol levels, whereas plant protein, example soy protein, dramatically lowers cholesterol levels. 24 studies in humans not only mirror these findings, but show that eating plant protein has even greater power to lower cholesterol levels than reducing fat or cholesterol intake. 25. While some of these studies implicating animal protein were conducted in the past 30 years, others were published well over 50 years ago when the health world was first beginning to discuss diet and heart disease. Yet somehow animal protein has remained in the shadows. while saturated fat and cholesterol have taken the brunt of the criticism. These three nutrients, fat, animal protein and cholesterol, characterize 120 The China Study. Chart 5.3, Heart Disease Death Rates for Men. Aged 55 to 59 years and animal protein consumption. Across 20 countries, see 6% of total calories coming from animal protein. 9. Animal-based food in general. So isn't it perfectly reasonable to wonder whether animal-based food, and not just these isolated nutrients, causes heart disease? Of course, no one pointed a finger at animal-based foods in general. It would have led immediately to professional isolation and ridicule. For reasons discussed in Part 4. These were contentious times in the nutritional world. A conceptual revolution was taking place, and a lot of people didn't like it. Even talking about diet was too much for many scientists. Preventing heart disease by diet was a threatening idea, because it implied that something about the good old meaty American diet was so bad for us that it was destroying our hearts. The status quo. Boys didn't like it. One status quo scientist had a good time making fun of people who appeared to have a low risk of heart disease. In 1960, he wrote the following piece of humor to mock the then recent findings. 26. Thumbnail sketch of the man least likely to have coronary heart disease. An effeminate municipal worker or embalmer, completely lacking in physical and mental alertness and without drive, ambition or competitive spirit, who has never attempted to meet a deadline of any kind. A man with poor appetite, subsisting on fruit and vegetables laced with corn and whale oils, detesting tobacco, spurning broken hearts. 121. Ownership of radio, TV, or motor car, with full head of hair and scrawny and unathletic in appearance, yet constantly straining his puny muscles by exercise, low in income, B.P., blood pressure, blood sugar, uric acid, and cholesterol, who has been taking nicotinic acid, pyridoxine and long-term anticoagulant therapy ever since his prophylactic castration. The author of this passage might just as well have said, only real men have heart disease. Also notice how a diet of fruits and vegetables is described as poor, even though the author suggests that this diet is eaten by those people who are least likely to have heart disease. The unfortunate association of meat with physical ability, general manliness, sexual identity and economic wealth all cloud how the status quo scientists viewed food, regardless of the health evidence. This view had been passed down from the early protein pioneers described in Chapter 2. Perhaps this author should have met a friend of mine, Chris Campbell, no relation. Chris is a two-time NCAA Division I wrestling champion, three-time U.S. senior wrestling champion, two-time Olympic wrestler and Cornell Law School graduate. At the age of 37, he became the oldest American ever to win an Olympic medal in wrestling, weighing in at 198 pounds. Chris Campbell is a vegetarian. As a man not likely to have heart disease, I think he might disagree with the characterization above. The battle between the status quo and the dietary prevention camp was intense. I remember attending a lecture at Cornell University during the late 1950s when a famous researcher, Ansel Keys, came to talk about preventing heart disease by diet. Some scientists in the audience just shook their heads in disbelief, saying diet can't possibly affect heart disease. In those first decades of heart disease research, a heated, personal battle flared, and open-mindedness was the first casualty. Recent history. Today, this epic battle between defenders of the status quo and advocates of diet is as strong as ever. but there have been significant changes in the landscape of heart disease. How far have we come, and how have we proceeded to fight this disease? Mostly, the status quo has been protected. Despite the potential of diet and disease prevention, most of the attention given to heart disease has been on mechanical and chemical intervention for those people who have advanced disease. Diet has been 122. The China study pushed aside. Surgery, drugs, electronic devices, and new diagnostic tools have stolen the spotlight. We now have coronary bypass surgery, where a healthy artery is pasted over a diseased artery, thereby bypassing the most dangerous plaque on the artery. The ultimate surgery, of course, is the heart transplant, which even utilizes an artificial heart on occasion. We also have a procedure that doesn't require cracking the chest plate open, called coronary angioplasty, where a small balloon is inflated in a narrowed, diseased artery, squishing the plaque back against the wall, opening up the passage for increased blood flow. We have defibrillators to revive hearts, pacemakers, and precise imaging techniques so that we can observe individual arteries without having to expose the heart. The past 50 years have truly been a celebration of chemicals and technology, as opposed to diet and prevention. In summarizing the initial widespread research on heart disease, one doctor recently highlighted the mechanical. It was hoped that the strength of science and engineering developed after World War II could be applied to this battle against heart disease. The enormous advances in mechanical engineering and electronics that had been stimulated by the war seemed to lend themselves particularly well to the study of the cardiovascular system. 4. Some great advances have been made, to be sure, which may account for the fact that our death rate from heart disease is a full 58% lower than what it was in 1950. A 58% reduction in the death rate seems a great victory for chemicals and technology. One of the greatest strides has come from better emergency room treatment of heart attack victims. In 1970, if you were older than 65 years, had a heart attack, and were lucky enough to make it to the hospital alive, you had a 38% chance of dying. Today, if you make it to the hospital alive, you only have a 15% chance of dying. The hospital's emergency response is much better, and consequently huge numbers of lives are being spared. 2. In addition, the number of people smoking has steadily been decreasing 27,28, which in turn lowers our death rate from heart disease. Between hospital advances, mechanical devices, drug discoveries, lower smoking rates, and more surgical options, there clearly seems to be much to cheer about. We've made progress, so it seems. Or have we? Broken hearts 123. After all, heart disease is still our number one cause of death. Every 24 hours, almost 2,000 Americans will die from this disease. 2. For all the advances, there are a huge number of people still succumbing to broken hearts. In fact, the incidence rate, not death rate, for heart disease 29 is about the same as it was in the early 1970s. 2. In other words, while we don't die as much from heart disease, we still get it as often as we used to. It seems that we simply have gotten slightly better at postponing death from heart disease, but we have done nothing to stop the rate at which our hearts become diseased. Surgery, the phantom savior. The mechanical interventions that we use in this country are much less effective than most people realize. Bypass surgery has become particularly popular. As many as 380,000 bypass operations were performed in 1990, 3 meaning that about out of 750 Americans underwent this extreme surgery. During the operation, the patient's chest is split open. Blood flow is rerouted by a series of clamps, pumps, and machines, and a leg vein or chest artery is cut out and sewn over a diseased part of the heart, thereby allowing blood to bypass the most clogged arteries. The costs are enormous. More than 1 of every 50 elective patients will die because of complications. 31 during the $46,000 procedure. 32. Other side effects include heart attack, respiratory complications, bleeding complications, infection, high blood pressure, and stroke. When the vessels around the heart are clamped shut during the operation, plaque breaks off of the inner walls. Blood then carries this debris to the brain, where it causes numerous mini strokes. Researchers have compared the intellectual capabilities of patients before and after the operation, and found that a stunning 79% of patients showed impairment in some aspect of cognitive function 7 days after the operation. 33. Why do we put ourselves through this? The most pronounced benefit of this procedure is relief of angina, or chest pain. About 70 to 80% of patients who undergo bypass surgery remain free of this crippling chest pain for 1 year. 34. But this benefit doesn't last. Within 3 years of the operation, up to 1/3 of patients will suffer from chest pain again. 35. Within 10 years, half of the bypass patients will have died, had a heart attack, or had their chest pain return. 36. Long-term studies indicate that only certain subsets of heart disease patients live longer because of their bypass operation. Why? Furthermore, these studies demonstrate that those 124, the China study, patients who undergo bypass operation do not have fewer heart attacks than those who do not have surgery. 12. Remember which plaque buildups cause heart attacks? The deadly buildups are the smaller, less stable plaques that tend to rupture. The bypass operation, however, is targeted to the largest, most visible plaques, which may be responsible for chest pain, but not for heart attacks. Angioplasty is a similar story. The procedure is expensive and carries significant risks. After identifying blockages in a coronary artery, a balloon is inserted into the artery and inflated. It pushes the plaque back against the vessel, thereby allowing more blood to flow. Roughly 1 out of 16 patients will experience an abrupt vessel closure during the procedure, which can lead to death, heart attack, or an emergency bypass operation. 3. Assuming that doesn't happen, there is still a good chance that the procedure will fail. Within 4 months after the procedure, 40% of the arteries that were squished open will close up again, effectively nullifying the procedure. 38. Nonetheless, barring these unfavorable outcomes, angioplasty does a good job of providing temporary relief of chest pain. Of course, angioplasty does little to treat the small blockages that are most likely to lead to heart attacks. So, upon closer examination, our seemingly beneficent mechanical advances in the field of heart disease are severely disappointing. Bypass surgery and angioplasty do not address the cause of heart disease, prevent heart attacks, or extend the lives of any but the sickest heart disease patients. What's going on here? Despite the positive public relations surrounding the past 50 years of heart disease research, we must ask ourselves, are we winning this war? Maybe we should ask ourselves what we might do differently. For example, whatever happened to the dietary lessons learned 50 years ago? Whatever happened to the dietary treatments discovered by Dr. Lester Morrison, as discussed earlier. Those discoveries largely faded away. I only learned about this 1940s and 1950s research in recent years. I am bewildered because the professionals I heard during my graduate student days in the late 1950s and early 1960s vigorously denied that any such work was being done or even being contemplated. In the meanwhile, America's eating habits have only gotten worse. According to the U.S. Department of Agriculture, we consume significantly more meat and added fat than we did 30 years ago. 39 Clearly we are not moving in the right direction. Broken Hearts 125. As this information has resurfaced in the past 2 decades, the fight against the status quo has been heating up again. A few rare doctors are proving that there is a better way to defeat heart disease. They are demonstrating revolutionary success, using the most simple of all treatments. Food. Dr. Caldwell B. Esselstyn, Jr. If you were to guess the location of the best cardiac care center in the country, maybe the world, what city would you name? New York? Los Angeles? Chicago? A city in Florida, perhaps, near elderly people? As it turns out, the best medical center for cardiac care is located in Cleveland, Ohio, according to U.S. News and World Report. Patients fly into the Cleveland Clinic from all over the world for the most advanced heart treatment available, administered by prestigious doctors. One of the doctors at the clinic, Dr. Caldwell B. Esselstyn, Jr., has quite a resume. As a student at Yale University, Dr. Esselstyn rode in the 1956 Olympics, winning a gold medal. After being trained at the Cleveland Clinic, he went on to earn the Bronze Star as an Army surgeon in the Vietnam War. He then became a highly successful doctor at one of the top medical institutions in the world, the Cleveland Clinic, where he was president of the staff, member of the Board of Governors, chairman of the Breast Cancer Task Force and head of the section of thyroid and parathyroid surgery. Having published over 100 scientific papers, Dr. Esselstyn was named one of the best doctors in America in 1994. 1995.40 From knowing this man personally, I get the feeling that he has excelled at virtually everything he has done in his life. He reached the pinnacle of success in his professional and personal life, and did it with grace and humility. The quality I find most appealing about Dr. Esselstyn, however, is not his resume or awards, it is his principled search for the truth. Dr. Esselstyn has had the courage to take on the establishment for the second National Conference on Lipids in the Elimination and Prevention of Coronary Artery Disease, which he organized and in which he kindly asked me to participate, Dr. Esselstyn wrote. 11 years into my career as a surgeon, I became disillusioned with the treatment paradigm of U.S. medicine in cancer and heart disease. Little had changed in 100 years in the management of cancer, and in neither heart disease nor cancer was there a serious 126 The China study effort at prevention. I found the epidemiology of these diseases provocative. However, 3/4 of the humans on this planet had no heart disease, a fact strongly associated with diet. Why? Dr. Esselstyn started to re-examine the standard medical practice, aware that medical, angiographic, and surgical interventions were treating only the symptoms of heart disease and believing that a fundamentally different approach to treatment was necessary. Dr. Esselstyn decided to test the effects of a whole foods, plant-based diet on people with established coronary disease. 42 by using a minimal amount of cholesterol-lowering medication and a very low-fat, plant-based diet, he has gotten the most spectacular results ever recorded in the treatment of heart disease. 42, 43. In 1985, Dr. Esselstyn began his study with the primary goal of reducing his patients' blood cholesterol to below 150 mg LDL. He asked each patient to record everything he or she ate in a food diary. Every 2 weeks, for the next 5 years, Dr. Esselstyn met with his patients to discuss the process, administer blood tests and record blood pressure and weight. He followed up this daytime meeting with an evening telephone call to report the results of the blood tests and further discuss how the diet was working. In addition, all of his patients met together a few times a year to talk about the program, socialize and exchange helpful information. In other words, Dr. Esselstyn was diligent, involved, supportive and compassionately stern on a personal level with his patients. The diet they, including Dr. Esselstyn and his wife Anne, followed was free of all added fat and almost all animal products. Dr. Esselstyn and his colleagues report, participants 1 were to avoid oils, meat, fish, fowl, and dairy products, except for skim milk and non-fat yogurt. 42 About 5 years into the program, Dr. Esselstyn recommended to his patients that they stop consuming any skim milk and yogurt, as well. 5 of his patients dropped out of the study within the first 2 years, that left 18. These 18 patients originally had come to Dr. Esselstyn with severe disease. Within the 8 years leading up to the study, these 18 people had suffered through 49 coronary events, including angina, bypass surgery, heart attacks, strokes, and angioplasty. These were not healthy hearts. One might imagine that they were motivated to join the study by the panic created when premature death is near. 42,43. Broken hearts. 127. These 18 patients achieved remarkable success. At the start of the study, the patient's average cholesterol level was 246 mg LDL. During the course of the study, the average cholesterol was 132 mg/dl, well below the 150 mg/dl target. 43 Their levels of bad LDL cholesterol dropped just as dramatically. 42 In the end, though, the most impressive result was not the blood cholesterol levels, but how many coronary events occurred since the start of the study. In the following 11 years, there was exactly 1 coronary event among the 18 patients who followed the diet. That one event was from a patient who strayed from the diet for 2 years. After straying, the patient consequently experienced clinical chest pain, angina, and then resumed a healthy plant-based diet. The patient eliminated his angina, and has not experienced any further events. Why? Not only has the disease in these patients been stopped, it has even been reversed. 70% of his patients have seen an opening of their clogged arteries. 43 11 of his patients had agreed to angiography, a procedure in which specific arteries in the heart can be x-rayed. Of these 11, the blockages in the arteries were, on average, reduced in size by 7% over the first 5 years of his study. This may sound like a small change, but it should be noted that the volume of blood delivered is at least 30% greater when the diameter is increased by 7%. 44 More importantly, this is the difference between the presence of pain from angina and absence of pain, indeed between life and death. Authors of the 5-year report note, This is the longest study of minimal fat nutrition used in combination with cholesterol-lowering drugs conducted to date, and our finding of a mean decrease of arterial stenosis blockage of 7% is greater than any reports in previous research. 42. One physician took special note of Dr. Esselstyn's study. He was only 44 years of age and seemingly healthy when he found himself with a heart problem, culminating in a heart attack. Because of the nature of his heart disease, there was nothing that conventional medicine could safely offer him. He visited Dr. Esselstyn, decided to commit to the dietary program, and after 32 months, without any cholesterol-lowering medication, he reversed his heart disease and lowered his blood cholesterol to 89 mg/dl. What follows is the dramatic image of this patient's diseased artery before and after Dr. Esselstyn's dietary advice. Chart 5.4.8. The light part of the picture is blood flowing through an artery. The picture on the left, A, has a section marked by a parenthesis, where severe coronary disease reduced the amount of blood flow. After 128. The China study. Chart 5.4, coronary artery before and after. Consuming plant-based diet. Adopting a whole foods, plant-based diet, that same artery opened up, reversing the ravages of heart disease and allowing a much more normal blood flow, as shown in the picture on the right. B. Is it possible that Dr. Esselstyn just got a lucky group of patients? The answer is no. Patients this sick with heart disease don't spontaneously heal themselves. Another way to check the likelihood of this degree of success is to look at the 5 patients that dropped out of the dietary program and resumed their standard care. As of 1995, these 5 people had fallen prey to 10 new coronary events. Meanwhile, as of 2003, 17 years into the study, all but 1 patient following the diet are still alive, headed into their 70s and 80s. 45. Broken hearts. 129. Can any sane person dispute these findings? It seems impossible. If you remember nothing else about this chapter, remember the 49-0 score, 49 coronary events prior to a whole foods, plant-based diet, and 0 events for those patients who adhered to a whole foods, plant-based diet. Dr. Esselstyn has done what big science has been trying to do, without success, for over 55 years. He defeated heart disease. Dr. Dean Ornish. In the past 15 years, another giant in this field, Dr. Dean Ornish, has been instrumental in bringing diet to the forefront of medical thought. A graduate of Harvard Medical School, he has been featured prominently in popular media, succeeded in having his heart disease treatment plan covered by a number of insurance carriers and written several best-selling books. If you have heard of the Deagle heart disease connection, chances are that it may well be because of Dr. Ornish's work. His best-known research is the Lifestyle Heart Trial, in which he treated 28 heart disease patients with lifestyle changes alone. 46. He put these patients on an experimental treatment plan and 20 additional patients on the standard treatment plan. He followed both groups carefully and measured several health indicators, including artery blockages, cholesterol levels, and weight. Dr. Ornish's treatment plan was very different from the standards of high-tech modern medicine. He put the 28 patients in a hotel for the first week of treatment and told them what they had to do to take control of their health. He asked them to eat a low-fat, plant-based diet for at least a year. Only about 10% of their calories were to come from fat. They could eat as much food as they wanted, as long as it was on The acceptable food list, which included fruits, vegetables, and grains. As researchers noted, no animal products were allowed except egg white, and 1 cup per day of non-fat milk or yogurt. 46. In addition to diet, the group was to practice various forms of stress management, including meditation, breathing exercises, and relaxation exercises for at least 1 hour per day. The patients were also asked to exercise 3 hours per week at levels customized to the severity of their disease. To help the patients make these lifestyle changes, the group met twice a week for 4 hours at a time for mutual support. Dr. Omish and his research group did not use any drugs, surgery, or technology to treat these patients. 46. The experimental patients adhered to pretty much everything that 130. The China study. The researchers asked of them and were rewarded with improved health and vitality. On average, their total cholesterol dropped from 227 mg LDL to 172 mg LDL, and their bad LDL cholesterol dropped from 152 mg LDL to 95 mg LDL. And after 1 year, the frequency, duration, and severity of their chest pains plummeted. Further, it was clear that the closer the patients adhered to the lifestyle recommendations, the more their hearts healed. The patients who had the best adherence over the course of the year saw the blockages in their arteries diminish by over 4%. 4% may seem like a small number, but remember that heart disease builds up over a lifetime, so a 4% change in only a year is a fantastic result. In all, 82% of the patients in the experimental group had regression in their heart disease over the course of a year. The control group did not fare so well, despite the fact that they received the usual care. Their chest pain became worse in terms of frequency, duration, and severity. For example, although the experimental group experienced a 91% reduction in the frequency of chest pain, the control group experienced a 165% rise in the frequency of chest pain. Their cholesterol levels were significantly worse than those of the experimental patients, and the blockages in their arteries also became worse. The patients in the group who were the least attentive to diet and lifestyle changes had blockages that increased in size by 8% over the course of the year. 46. Between Dr. Amish, Dr. Esselstyn and others before them, like Dr. Morrison, I believe that we have found the strategic link in our heart disease battle plan. Their dietary treatments not only relieve the symptoms of chest pain, but they also treat the cause of heart disease and can eliminate future coronary events. There are no surgical or chemical heart disease treatments at the Cleveland Clinic or anywhere else that can compare to these impressive results. The future is filled with hope. We now know enough to nearly eliminate heart disease. We know not only how to prevent the disease, but how to successfully treat it. We do not need to crack open our breastplates to reroute our arteries, and we do not need a lifetime of powerful drugs in our blood. By eating the right food, we can keep our hearts healthy. The next step is to implement this dietary approach on a large scale, which is exactly what Dr. Dean Omish is currently working on. His research group has begun the multi-center lifestyle demonstration project, which represents the future of heart disease healthcare. Teams. Broken Hearts. 131 of health professionals at 8 diverse sites have been trained to treat heart disease patients with Dr. Omish's lifestyle intervention program. Patients eligible to participate are those who have documented heart disease severe enough to warrant surgery, Instead of surgery, they may enroll in a 1-year lifestyle program. This program was started in 1993. And by 1998 there were 40 insurance programs that covered the costs for selected patients. 32. As of 1998, almost 200 people had taken part in the lifestyle project. And the results are phenomenal. After 1 year of treatment, 65% of patients had eliminated their chest pain. The effect was long-lasting, as well. After 3 years, over 60% of the patients continued reporting no chest pain. 32. The health benefits are equaled by the economic benefits. Over 1 million heart disease surgeries are undertaken every year. 32. In 2002, physician services and hospital care for heart disease patients cost $78.10 billion. That does not include drug costs, home health care or nursing home care. Point 2. The angioplasty procedure alone costs $31,000, and bypass surgery costs $46,032. In marked contrast, the year-long lifestyle intervention program only costs $7,000. By comparing the patients who underwent the lifestyle program with those patients who underwent the traditional route of surgery, Dr. Omish and his colleagues demonstrated that the lifestyle intervention program cut costs by an average of $30,000 per patient. 32. Much work remains to be done. The healthcare establishment is structured to profit from chemical and surgical intervention. Diet still takes the backseat to drugs and surgery. One criticism that is constantly leveled at the dietary argument is that patients will not make such fundamental changes. One doctor charges that Dr. Esselstyn's patients change their eating habits simply because of Esselstyn's zealous belief. 47. This criticism is not only wrong and insulting to patients, it is also self-fulfilling. If doctors do not believe that patients will change their diets, they will neglect to talk about diet, or will do it in an offhanded, disparaging way. There is no greater disrespect a doctor can show patients than that of withholding potentially life-saving information based on the assumption that patients do not want to change their lifestyle. Well-meaning institutions are not exempt from such closed-mindedness. The American Heart Association recommends a diet for heart disease that favors moderation, rather than scientific truth. The National Cholesterol Education Program does the same thing. These organizations 132. The China Study pitch moderate diets with trivial changes as being healthy lifestyle goals. If you are at high risk for heart disease, or if you already have the disease, they recommend that you adopt a diet containing 30% of total calories as fat, 7% of total calories as saturated fat, and less than 200 milligrams per day of dietary cholesterol. 48,49. According to them, we should also keep our total blood cholesterol level under the desirable level of 200 mg/dl. 49. These venerable organizations are not giving the American public the most up-to-date scientific information. While we are told that a total blood cholesterol level of 200 mg/dl is desirable, we know that 35% of heart attacks strike Americans who have cholesterol levels between 150 and 200 mg/dpo. A truly safe cholesterol level is under 150 mg/dl. We also know that the most aggressive reversal of heart disease ever demonstrated occurred when fat was about low percent of total calorie intake. Studies have clearly demonstrated that many patients who follow the more moderate government-recommended diet see a progression of heart disease. 51. The innocent victims are health-conscious Americans who follow these recommendations. keeping their total cholesterol around 180 or 190 mg/dl, only to be rewarded with a heart attack leading to a premature death. To top it off, the National Cholesterol Education Program dangerously writes, lifestyle changes are the most cost-effective means to reduce risk for CHD, coronary heart disease. Even so, to achieve maximal benefit, many persons will require LDL cholesterol-lowering drugs 49. No wonder America's health is failing. The dietary recommendations for the most diseased hearts among us, given by supposedly reputable institutions, are severely watered down and followed by the caveat that we'll probably need a lifetime of drugs anyway. Our leading organizations fear that if they advocate more than modest changes, no one will listen to them. But the establishment recommended diets are not nearly as healthy as the diets espoused by Drs. Esselstyn and Omish. The fact is that a blood cholesterol level of 200 mg/dl is not safe, a 30% fat diet is not low fat, and eating foods containing any cholesterol above 0 milligrams is unhealthy. Our health institutions are intentionally misleading the public about heart disease, all in the name of moderation. Whether scientists, doctors, and policymakers think the public will change or not, the layperson must be aware that a whole foods, plant-based diet is far and away the healthiest diet. In the seminal paper regarding the landmark lifestyle heart trial, the authors, Dr. Omish and Broken Hearts 133, his scientific colleagues, write, the point of our study was to determine what is true, not what is practicable. Emphasis 46. We now know what is true. A whole foods, plant-based diet can prevent and treat heart disease, saving hundreds of thousands of Americans every year. Dr. William Castelli, the longtime director of the Framingham Heart Study, a cornerstone of heart disease research, espouses a whole foods, plant-based diet. Dr. Esselstyn, who has demonstrated the most significant reversal of heart disease in all of medical history, espouses a whole foods, plant-based diet. Dr. Ornish, who has pioneered reversal of heart disease without drugs or surgery and proved widespread economic benefit for patients and insurance providers, espouses a whole foods, plant-based diet. Now is a time of great hope and challenge, a time when people can control their health. One of the best and most caring doctors I have ever met puts it best. The collective conscience and will of our profession is being tested as never before. Now is the time for us to have the courage for legendary work. Dr. Caldwell B. Esselstyn Jr. Obesity. Perhaps you've heard the news. Perhaps you've caught a glimpse of the staggering statistics on obesity among Americans. Perhaps you've simply noticed that, compared to a few years ago, more people at the grocery store are overweight. Perhaps you've been in classrooms, on playgrounds, or at daycare centers and noticed how many kids are already crippled with the weight problem and can't run 20 feet without getting winded. Our struggle with weight is hard to miss these days. Open a newspaper or a magazine, or turn on the radio or TV, you know that America has a weight problem. In fact, 2 out of 3 adult Americans are overweight, and 1/3 of the adult population is obese. Not only are these numbers high, but the rate at which they have been rising is ominous. Chart L.2, page 13.1. But what do the terms overweight and obese mean? The standard expression of body size is the body mass index, BMI. It represents body weight, in kilograms, kg, relative to body height, in meters squared. M2. By most official standards, Being overweight is having a BMI above 25, and being obese is having a BMI over 30. The same scale is used for both men and women. You can determine your own BMI using chart 6.1, which lists the necessary information in pounds and inches for your convenience. 135. 136. The HENA study. Chart 6.1, Body Mass Index Table. Normal, overweight, obese. The children. Perhaps the most depressing element of our supersize mess is the growing number of overweight and obese children. About 15% of America's youth ages 6 to 19 are overweight. Another 15% are at risk of becoming overweight. 2. Overweight children face a wide range of psychological and social challenges. As you know, children have a knack for being open and obesity. 137. Blunt. Sometimes the playground can be a merciless place. Overweight children find it more difficult to make friends and are often thought of as lazy and sloppy. They are more likely to have behavioral and learning difficulties, and the low self-esteem likely to be formed during adolescence can last forever. 3. Young people who are overweight also are highly likely to face a host of medical problems. They often have elevated cholesterol levels, which can be a predictor for any number of deadly diseases. They are more likely to have problems with glucose intolerance, and, consequently, diabetes. Type 2 diabetes, formerly seen only in adults, is skyrocketing among adolescents. See chapters 7 and 9 for a more thorough discussion of childhood diabetes. Elevated blood pressure is 9 times more likely to occur among obese kids. Sleep apnea, which can cause neurocognitive problems, is found in 1 in 10 obese children. A wide variety of bone problems is more common in obese kids. Most importantly, an obese young person is much more likely to be an obese adult. 3. Greatly increasing the likelihood of lifelong health problems. Consequences for the adult. If you are obese, you may not be able to do many things that could make your life more enjoyable. You may find that you cannot play vigorously with your grandchildren, or your children, walk long distances, participate in sports, find a comfortable seat in a movie theater or airplane, or have an active sex life. In fact, even sitting still in a chair may be impossible without experiencing back or joint pain. For many, standing is hard on the knees. Carrying around too much weight can dramatically affect physical mobility, work, mental health, self-perception, and social life. So you see, this isn't about death, it really is about missing many of the more enjoyable things in life. 4. Clearly no one desires to be overweight. So why is it that 2 out of 3 adult Americans are overweight? Why is 1/3 of the population obese? The problem is not a lack of money. In 1999, medical care costs relating to obesity alone were estimated to be $70 billion. 5 in 2002, a mere 3 years later, the American Obesity Association listed these costs at $100 billion. 6. This is not all. Add another $30 to $40 billion out of pocket money that we spend trying to keep off the weight in the first place. 5. Going on special weight loss diet plans and popping pills to cut our appetites or rearrange our metabolism have become a national pastime. 138. The China study. This is an economic black hole that sucks our money away without offering anything in return. Imagine paying $40 to a serviceman to fix your leaky kitchen sink, and then 2 weeks later, the sink pipes explode and flood the kitchen and it costs $500 to repair. I bet you wouldn't ask that guy to fix your sink again. So then why do we endlessly try those weight loss plans, books, drinks, energy bars, and assorted gimmicks when they don't deliver as promised? I applaud people for trying to achieve a healthy weight. I don't question the worthiness or dignity of overweight people any more than I question cancer victims. My criticism is of a societal system that allows and even encourages this problem. I believe, for example, that we are drowning in an ocean of very bad information, too much of it intended to put money into someone else's pockets. What we really need, then, is a new solution comprised of good information for individual people to use at a price that they can afford. The solution to losing weight is a whole foods, plant-based diet, coupled with a reasonable amount of exercise. It is a long-term lifestyle change, rather than a quick fix fad, and it can provide sustained weight loss while minimizing risk of chronic disease. Have you ever known anyone who regularly consumes fresh fruits, vegetables and whole grain foods and rarely, if ever, consumes meats or junk foods like chips, French fries and candy bars? What is his or her weight like? If you know many people like this, you have probably noticed that they tend to have a healthy weight. Now think of traditional cultures around the world. Think of traditional Asian cultures, Chinese, Japanese, Indian, where a couple of billion people have been eating a mostly plant-based diet for thousands of years. It's hard to imagine these people, at least until recently, as anything other than slender. And now imagine a guy buying 2 hot dogs and ordering his second beer at a baseball game, or a woman ordering a cheeseburger and fries at your local fast food joint. The people in these images look different, don't they? Unfortunately, the guy munching his hot dogs and sipping his beer is rapidly becoming the all-American image. I have had visitors from other countries tell me that one of the first things they notice when they arrive in our good land is the exceptional number of fat people. Solving this problem does not require magic tricks or complex equations involving blood types or carbohydrate counting or soul. Obesity 139. Searching. Simply trust your observations on who is slim, vigorous, and healthy, and who is not. Or trust the findings of some impressive research studies, large and small, showing time and time again that vegetarians and vegans are slimmer than their meat-eating counterparts. People in these studies who are vegetarian or vegan are anywhere from 5 to 30 pounds slimmer than their fellow citizens. 7J3. In a separate intervention study, overweight subjects were told to eat as much as they wanted of foods that were mostly low-fat, whole food and plant-based. In 3 weeks these people lost an average of 17 pounds. 14. At the Pritikin Center, 4,500 patients who had gone through their 3-week program got similar results. By feeding a mostly plant-based diet and promoting exercise, the center found that its clients lost 5.5% of their body weight over 3 weeks. 15. Published results for still more intervention studies using a low-fat, whole foods, mostly plant-based diet. About 2 to 5 pounds lost after 12 days. 6. About 10 pounds lost in 3 weeks. Low 7. 18. 16 pounds lost over 12 weeks. Low 9. 24 pounds lost after 1 year. 20. All of these results show that consuming a whole foods, plant-based diet will help you to lose weight, and, furthermore, it can happen quickly. The only question is how much weight you can lose. In most of these studies, the people who shed the most pounds were those who started with the most excess weight. 21. After the initial weight loss, the weight can be kept off for the long term by staying on the diet. Most importantly, losing weight this way is consistent with long-term health. Some people, of course, can be on a plant-based diet and still not lose weight. There are a few very good reasons for this. First and foremost, losing body weight on a plant-based diet is much less likely to occur if the diet includes too many refined carbohydrates. Sweets, pastries and pastas won't do it. These foods are high in readily digested sugars and starches and, for the pastries, oftentimes very high in fat as well. As mentioned in Chapter 4, these highly processed, unnatural foods are not part of a plant-based diet that works to reduce body weight and promote health. This is one of the main reasons that I usually refer to the optimal diet as a whole foods, plant-based diet. Notice that a strict vegetarian diet is not necessarily the same thing. 140. The HENA study. As a whole foods, plant-based diet. Some people become vegetarian only to replace meat with dairy foods, added oils, and refined carbohydrates, including pasta made with refined grains, sweets, and pastries. I refer to these people as junk food vegetarians because they are not consuming a nutritious diet. The second reason weight loss may be elusive is if a person never engages in any physical activity. A reasonable amount of physical activity, sustained on a regular basis, can pay important dividends. Thirdly, certain people have a family predisposition for overweight bodies that may make their challenge more difficult. If you are one of these people, I can only say that you probably need to be especially rigorous in your diet and exercise. In rural China, we noticed that obese people simply did not exist, even though Chinese immigrants in Western countries do succumb to obesity. Now, as the dietary and lifestyle practices of people in China are becoming more like ours, so too have their bodies become more like ours. For some of these people with genetic predispositions, it doesn't take much bad food before their change in diet starts to cause problems. Keeping body weight off is a long-term lifestyle choice. Gimmicks that produce impressively large, quick weight losses don't work in the long term. Short-term gains should not come along with long-term pain, like kidney problems, heart disease, cancer, bone and joint ailments, and other problems that may be brought on with popular diet fads. If the weight was gained slowly, over a period of months and years, why would you expect to take it off healthily in a matter of weeks? Treating weight loss as a race doesn't work, it only makes the eater more eager to quit the diet and go back to the eating habits that put them in need of losing weight in the first place. One very large study of 21,105 vegetarians and vegans 13 found that body mass index was lower among those who had adhered to their diet for 5 or more years compared to people who had been on the diet for less than 5 years. Why this will work for you? So there is a solution to the weight gain problem. But how can you apply it to your own life? First of all, throw away ideas about counting calories. Generally speaking, you can eat as much as you want and still lose weight as long you eat the right type of food. See Chapter 12 for details. Secondly, stop expecting sacrifice, deprivation or blandness. There's no need. Feeling obesity 141. Hungry is a sign that something is wrong, and prolonged hunger causes your body to slow the overall rate of metabolism in defense. Moreover, there are mechanisms in our bodies that naturally allow the right kind of plant-based foods to nourish us, without our having to think about every morsel of food we put in our mouths. It is a worry-free way to eat. Give your body the right food and it will do the right thing. In some studies, those who follow a whole foods, low-fat, plant-based diet consume fewer calories. It's not because they're starving themselves. In fact, they will likely spend more time eating and eat a larger volume of food than their meat-eating counterparts. 22 That's because fruits, vegetables, and grains as whole foods are much less energy-dense than animal foods and added fats. There are fewer calories in each spoonful or cupful of these foods. Remember that fat has 9 calories per gram, while carbohydrates and protein have only 4 calories per gram. In addition, whole fruits, vegetables, and grains have a lot of fiber, which makes you feel full 22, 23, and yet contributes almost no calories to your meal. So by eating a healthy meal, you may reduce the calories that you consume, digest and absorb, even if you eat significantly more food. This idea on its own, however, is not yet a sufficient explanation for the benefits of a whole foods, plant-based diet. The same criticisms I made against the Atkins diet and the other popular low-carb diets, Chapter 4, can also be applied to short-term studies in which subjects consume fewer calories while eating a plant-based diet. Over the long term, these subjects will find it very difficult to continue consuming an abnormally low level of calories. Weight loss due to calorie restriction rarely leads to long-term weight loss. This is why other studies play such a crucial part in explaining the health benefits of a whole foods, plant-based diet, studies that show that the weight loss effect is due to more than simple calorie restriction. These studies document the fact that vegetarians consume the same amount or even significantly more calories than their meat-eating counterparts, and yet are still slimmer. 11, 24, 25 The China study demonstrated that rural Chinese consuming a plant-based diet actually consume significantly more calories per pound of body weight than Americans. Most people would automatically assume that these rural Chinese would therefore be heavier than their meat-eating counterparts. But here's the kicker: the rural Chinese are still slimmer while consuming a greater volume of food and more calories. Much of this effect is undoubtedly due to greater physical activity, but this comparison is between average 142 THECHINA stu-dy Americans and the least active Chinese, those who do office work. Furthermore, studies done in Israel and the United Kingdom neither of which represent primarily agrarian cultures, also show that vegetarians may consume the same or significantly more calories and still weigh less. What's the secret? One factor that I've mentioned previously is the process of thermogenesis, which refers to our production of body heat during metabolism. Vegetarians have been observed to have a slightly higher rate of metabolism during rest 26, meaning they burn up slightly more of their ingested calories as body heat rather than depositing them as body fat. 27 A relatively small increase in metabolic rate translates to a large number of calories burned over the course of 24 hours. Most of the scientific basis for the importance of this phenomenon was presented in Chapter 4. Exercise. The slimming effect of physical activity is obvious. Scientific evidence concurs. A recent review of all the credible studies compared the relationship between body weight and exercise 28 and showed that people who were more physically active had less body weight. Another set of studies showed that exercising on a regular basis helped to keep off weight originally lost through exercise programs. No surprise here either. Starting and stopping an exercise program is not a good idea. It Is better to build it into your lifestyle so that you will become and continue to be more fit overall, not just burn off calories. How much exercise is needed to keep the pounds off? A rough estimate derived from a Good Review 28 suggested that exercising a mere 15 to 45 minutes per day, every day, will maintain a body weight that is 11 to 18 pounds lighter than it would otherwise be. Interestingly, we should not forget our spontaneous physical activity, the kind that is associated with chores of daily life. This can account for 100 to 800 calories per day, kcal. 9. 30 people who are regularly up and about doing physical things are going to be well ahead of those who get trapped in a sedentary lifestyle. The advantages of combining diet and exercise to control body weight were brought home to me by a very simple study involving our experimental animals. Recall that our experimental animals were fed diets containing either the traditional 20% casein, cow's milk protein, or the much lower 5% casein. The rats consuming the 5% casein diets, obesity 143, had strikingly less cancer, lower blood cholesterol levels and longer lives. They also consumed slightly more calories but burned them off as body heat. Some of us had noticed over the course of these experiments that the 5% casein animals seemed to be more active than the 20% casein animals. To test this idea, we housed rats fed either 5% or 20% casein diets in cages equipped with exercise wheels outfitted with meters to record the number of turns of the wheel. Within the very first day, the 5% casein-fed animals voluntarily exercised in the wheel about twice as much as the 20% casein-fed animals. 31 exercise remained considerably higher for the 5% casein animals throughout the 2 weeks of the study. Now we can combine some really interesting observations on body weight. A plant-based diet operates on calorie balance to keep body weight under control in 2 ways. First, it discharges calories as body heat instead of storing them as body fat, and it doesn't take many calories to make a big difference over the course of a year. Second, a plant-based diet encourages more physical activity. And, as body weight goes down, it becomes easier to be physically active. Diet and exercise work together to decrease body weight and improve overall health. Going in the right direction. Obesity is the most ominous harbinger of poor health that Western nations currently face. Tens of millions of people will fall prey to disability, putting our healthcare systems under greater strain than has previously been seen. There are many people and institutions working to reduce this problem, but their point of attack is often illogical and misinformed. First, there are the many quick fix promises and gimmicks. Obesity is not a condition that can be fixed in a few weeks or even a few months, and you should beware of diets, potions and pills that create rapid weight loss with no promise of good health in the future. The diet that helps to reduce weight in the short run needs to be the same diet that creates and maintains health in the long run. Second, the tendency to focus on obesity as an independent, isolated disease 33 is misplaced. Considering obesity in this manner directs our attention to a search for specific cures while ignoring control of the other diseases to which obesity is strongly linked. That is, we sacrifice context. Also, I would urge that we ignore the suggestion that knowing its genetic basis might control obesity. A few years ago, 34-36, there was great 144 the HENA study publicity given to the discovery of the obesity gene. Then there was the discovery of a second gene related to obesity, and a third gene, and a fourth, and on and on. The purpose behind the obesity gene search is to allow researchers to develop a drug capable of knocking out or inactivating the underlying cause of obesity. This is extremely short-sighted, as well as unproductive. Believing that specific identifiable genes are the basis of obesity, i.e., it's all in the family, also allows us to fatalistically blame a cause that we cannot control. We can control the cause. It is right at the end of our fork. 1. Diabetes. Type 2 diabetes, the most common form, often accompanies obesity. As we, as a nation, continue to gain weight, our rate of diabetes spirals out of control. In the 8 years from 1990 to 1998, the incidence of diabetes increased 33%. 1 over 8% of American adults are diabetic, and over 150,000 young people have the disease. That translates to 16 million Americans. The scariest figure? 1/3 of those people with diabetes don't yet know that they have it. 2. You know the situation is serious when our children, at the age of puberty, start falling prey to the form of diabetes usually reserved for adults over 40. One newspaper recently illustrated the epidemic with the story of a girl who weighed 350 pounds at the age of 15, had the adult onset form of diabetes and was injecting insulin into her body 3 times a day. 3. What is diabetes? Why should we care about it, and how do we stop it from happening to us? 2 faces of the same devil. Almost all cases of diabetes are either type 1 or type 2. Type 1 develops in children and adolescents, and thus is sometimes referred to as juvenile onset diabetes. This form accounts for 5% to 10% of all diabetes cases. Type 2, which accounts for 90% to 95% of all cases, used to occur primarily in adults age 40 and up, and thus was called adult onset diabetes. 2. But because up to 45% of new diabetes cases in children are type 2 diabetes, for the age-specific names are being dropped, and the 2 forms of diabetes are simply referred to as type 1 and type 2.4. 145. 146. The China study. In both types, the disease begins with dysfunctional glucose metabolism. Normal metabolism goes like this. We eat food. The food is digested and the carbohydrate part is broken down into simple sugars, much of which is glucose. Glucose, blood sugar, enters the blood, and insulin is produced by the pancreas to manage its transport and distribution around the body. Insulin, acting like an usher, opens doors for glucose into different cells for a variety of purposes. Some of the glucose is converted to short-term energy for immediate cell use, and some is stored as long-term energy, fat, for later use. As a person develops diabetes, this metabolic process collapses. Type 1 diabetics cannot produce adequate insulin because the insulin-producing cells of their pancreas have been destroyed. This is the result of the body attacking itself, making type 1 diabetes an autoimmune disease. Type 1 diabetes and other autoimmune diseases are discussed in Chapter 9. Type 2 diabetics can produce insulin, but the insulin doesn't do its job. This is called insulin resistance, which means that once the insulin starts giving orders to dispatch the blood sugar, the body doesn't pay attention. The insulin is rendered ineffective, and the blood sugar is not metabolized properly. Imagine your body as an airport, complete with vast parking areas. Each unit of your blood sugar is an individual traveler. After After you eat, your blood sugar rises. In our analogy, then, that means lots of travelers would start to arrive at the airport. The people would drive in, park in a lot and walk to the stop where the shuttle bus is supposed to pick them up. As your blood sugar continues to rise, all the airport parking lots would fill to capacity, and all the people would congregate at the shuttle bus stops. The shuttle buses, of course, represent insulin. In the diabetic airport, unfortunately, there are all sorts of problems with the buses. In the type 1 diabetic airport, the shuttle buses simply don't exist. The only shuttle bus manufacturer in the known universe, Pancreas Company, was shut down. In the type 2 diabetic airport, there are some shuttle buses, but they don't work very well. In both cases, travelers never get to where they want to go. The airport system breaks down, and chaos ensues. In real life, this corresponds with a rise in blood sugar to dangerous levels. In fact, diabetes, diabetes 147, is diagnosed by the observation of elevated blood sugar levels, or its spillage into urine. What are the long-term health risks of glucose metabolism being disrupted? Here's a summary, taken from a report from the Centers for Disease Control. Diabetes complications. Heart disease. 2 to 4 times the risk of death from heart disease. Stroke. 2 to 4 times the risk of stroke. High blood pressure. Over 70% of people with diabetes have high blood pressure. Blindness. Diabetes is the leading cause of blindness in adults. Kidney disease. Diabetes is the leading cause of end-stage kidney disease. Over 100,000 diabetics underwent dialysis or kidney transplantation in 1999. Nervous system disease. 60% to 70% of diabetics suffer mild to severe nervous system damage. Amputation. Over 60% of all lower limb amputations occur with diabetics. Dental disease. Increased frequency and severity of gum disease that can lead to tooth loss. Pregnancy complications. Increased susceptibility to other illnesses. Death. 148. The China study. Modern drugs and surgery offer no cure for diabetics. At best, current drugs allow diabetics to maintain a reasonably functional lifestyle, but these drugs will never treat the cause of the disease. As a consequence, diabetics face a lifetime of drugs and medications, making diabetes an enormously costly disease. The economic toll of diabetes in the U.S. over $130 billion a year. 2. But there is hope. In fact, there is much more than hope. The food we eat has enormous influence over this disease. The right diet not only prevents but also treats diabetes. What, then, is the right diet? You can probably guess what I'm going to say, but let the research speak for itself. Now you see it, now you don't. Like most chronic diseases, diabetes shows up more often in some parts of the world than in others. This has been known for 100 years. It has also been well documented that those populations with low rates of diabetes eat different diets than those populations with high rates of diabetes. But is that just a coincidence, or is there something else at work? Chart 7.1, Diets and Diabetes Rates, circa 19,254. 5% fat, percent carbohydrates. Diabetes. Diabetes 149. Almost 70 years ago, H.P. Hemsworth compiled all the existing research in a report comparing diets and diabetes rates in 6 countries. What he found was that some cultures were consuming high-fat diets, while others had diets high in carbohydrates. These fat vs. carbohydrate consumption patterns were the result of animal vs. plant food consumption. Chart 7.1 documents the diet and disease conditions for these countries in the early part of the 20th century. 5. As carbohydrate intake goes up and fat intake goes down, the number of deaths from diabetes plummets from 20.4 to 2.9 per 100,000 people. The verdict? A high carbohydrate, low fat diet, a plant-based diet may help to prevent diabetes. 30 years later, the question was re-examined. After examining 4 countries from Southeast Asia and South America, researchers again found that high carbohydrate diets were linked to low rates of diabetes. Researchers noted that the country with the highest rate of diabetes, Uruguay, had a diet that was typically Western in character, being high in calories, animal protein, total fat and animal fat. Countries with low rates of diabetes used a diet that was relatively lower in protein, particularly animal protein, fat, and animal fat. A high proportion of calories is derived from carbohydrates, particularly from rice. 6. These same researchers enlarged their study to 11 countries through Central and South America and Asia. The strongest association they found with diabetes was excess weight. Populations eating the most Western type of diet also had the highest cholesterol levels, which in turn was strongly associated with the rate of diabetes. Is this starting to sound familiar? Within one population, these old, cross-cultural studies can be crude, resulting in conclusions that are not entirely reliable. Perhaps the difference in diabetes rates in the above studies were not due to diet, but to genetics. Perhaps other unmeasured cultural factors, like physical activity, were more relevant. A better test would be a study of diabetes rates in a single population. The Seventh-day Adventists population is a good example. They are an interesting group of people to study because of their dietary habits. Their religion encourages them to stay away from meat, fish, eggs, coffee, alcohol, and tobacco. As a result, half of them are vegetarian. But 90% of these vegetarians still consume dairy and/or egg products, thus deriving a significant amount of their calories from animal sources. 150 The China study. Should also be noted that the meat-eating Adventists are not the meatiest of eaters. They consume about 3 servings of beef a week, and less than 1 serving a week of fish and poultry. 8 I know plenty of people who consume this amount of meat, including fish and poultry, every 2 days. In dietary studies involving the Adventists, scientists compare moderate vegetarians to moderate meat eaters. This is not a big difference. Even so, the Adventist vegetarians are much healthier than their meat-eating counterparts. 8 Those Adventists that deprive themselves of meat also deprive themselves of the ravages of diabetes. Compared to the meat eaters, the vegetarians had about 1/2 the rate of diabetes. 8,9 They also had almost half the rate of obesity. 8. In another study, scientists measured diets and diabetes in a population of Japanese American men in Washington state. 10 These men were the sons of Japanese immigrants to the U.S. Remarkably, they had more than 4 times the prevalence of diabetes than the average rate found in similar aged men who stayed in Japan. So what happened? For Japanese Americans, the ones who developed diabetes also ate The most animal protein, animal fat and dietary cholesterol, each of which is only found in animal-based foods. 0.10 total fat intake also was higher among the diabetics. These same dietary characteristics also resulted in excess weight. These second-generation Japanese Americans ate a meatier diet with less plant-based food than men born in Japan. The researchers wrote, apparently, the eating habits of Japanese men living in the United States resemble more the American eating style than the Japanese. The consequence, 4 times as much incidence of diabetes. 10. Some other studies. Researchers found that increased fat intake was associated with an increased rate of type 2 diabetes among 1,300 people in the San Luis Valley in Colorado. They said, the findings support the hypothesis that high-fat, low-carbohydrate diets are associated with the onset of non-insulin-dependent type 2 diabetes mellitus in humans. 11. In the past 25 years, the rate at which children in Japan contract type 2 diabetes has more than tripled. Researchers note that consumption of animal protein and animal fat has drastically increased in the past 50 years. Researchers say that this dietary diabetes 151 shift, along with low exercise levels, might be to blame for this explosion of diabetes. 12. In England and Wales, the rate of diabetes markedly dropped from 1940 to 1950, largely during World War II when food consumption patterns changed markedly. During the war and its aftermath, fiber and grain intake went up and fat intake went down. People ate lower on the food chain because of national necessity. Around 1950, though, people gave up the grain-based diets and returned to eating more fat, more sugar and less fiber. Sure enough, diabetes rates started going up. 13. Researchers studied 36,000 women in Iowa for 6 years. All were free of diabetes at the start of the study, but more than 1,100 cases of diabetes developed after 6 years. The women who were least likely to get diabetes were those that ate the most whole grains and fiber. 14. Those whose diets contained the most carbohydrates, the complex kind found in whole foods. All of these findings support the idea that both across and within populations, high fiber, whole, plant-based foods protect against diabetes, and high fat, high protein, animal-based foods promote diabetes. Curing the incurable. All of the research cited above was observational, and an observed association, even if frequently seen, may only be an incidental association that masks the real cause-effect relationship of environment, including diet and disease. There is, however, also research of the controlled or intervention variety. This involves changing the diets of people who already have either full-blown type 1 or type 2 diabetes or mild diabetic symptoms, impaired glucose tolerance. James Anderson, MD, is one of the most prominent scientists studying diet and diabetes today, garnering dramatic results using dietary means alone. One of his studies examined the effects of a high-fiber, high-carbohydrate, low-fat diet on 25 type 1 diabetics and 25 type 2 diabetics in a hospital setting. Why none of his 50 patients were overweight, and all of them were taking insulin shots to control their blood sugar levels. His experimental diet consisted mostly of whole plant foods and the equivalent of only a cold cut or 2 of meat a day. He put his patients on the conservative, American-style diet recommended by the American 152. The China Study Diabetes Association for 1 week and then switched them over to the experimental veggie diet for 3 weeks. He measured their blood sugar levels, cholesterol levels, weight, and medication requirements. The results were impressive. Type 1 diabetics cannot produce insulin. It is difficult to imagine any dietary change that might aid their predicament. But after just 3 weeks, the type 1 diabetic patients were able to lower their insulin medication by an average of 40%, while their blood sugar profiles improved dramatically. Just as importantly, their cholesterol levels dropped by 30%. PS. Remember, one of the dangers of being diabetic is the secondary outcomes, heart disease, and stroke. Lowering risk factors for those secondary outcomes by improving the cholesterol profile is almost as important as treating high blood sugar. Type 2 diabetics, unlike type 1, are more treatable because they haven't incurred such extensive damage to their pancreas. So when Anderson's type 2 patients ate the high-fiber, low-fat diet, the results were even more impressive. Of the 25 type 2 patients, 24 were able to discontinue their insulin medication. Let me say that again. All but one person were able to discontinue their insulin medication in a matter of weeks. PS. One man had a 21-year history of diabetes and was taking 35 units of insulin a day. After 3 weeks of intensive dietary treatment, his insulin dosage dropped to 8 units a day. After 8 weeks at home, his need for insulin shots vanished. 15 Chart 7.2 shows a sample of patients and how eating a plant-based diet lowered their insulin medications. This is a huge effect. In another study of 14 lean diabetic patients, Anderson found that diet alone could lower total cholesterol levels by 32% in just over 2 weeks. 16 Some of the results are shown in Chart 7.3. These benefits, representing a decrease in blood cholesterol from 206 mg/LDL to 141 mg/LDL, are astounding, especially considering the speed with which they appear. Dr. Anderson also found no evidence that this cholesterol decrease was temporary. As long as people continued on the diet, it remained low for 4 years. Why? Another group of scientists at the Pritikin Center achieved equally spectacular results by prescribing a low-fat, plant-based diet and exercise to a group of diabetic patients. Of 40 patients on medication at the start of the program, 34 were able to discontinue all medication after only 26 days. This research group also demonstrated that diabetes 153. Chart 7.2, insulin dosage response to diet control. -60. HCF diet. High carbohydrate. High fiber diet. Type 2 patients. 6-12 days. N equals 8. N equals. The benefits of a plant-based diet will last for years if the same diet is continued. L9. These are examples of some very dramatic research, but they only scratch the surface of all the supporting research that has been done. One scientific paper reviewed 9 publications citing the use of high carbohydrate, high fiber diets and 2 more standard carbohydrate, high fiber diets to treat diabetic patients. All 11 studies resulted in improved blood sugar and cholesterol levels. Dietary fiber supplements, by the way, although beneficial, did not have same consistent effects as a change to a plant-based, whole foods diet. The persistence of habit. As you can see by these findings, we can beat diabetes. 2 recent studies considered a combination of diet and exercise effects on this disease. 23 One study placed 3,234 non-diabetic people at risk for diabetes, elevated blood sugar, into 3 different groups. Y1 group. The control received standard dietary information and a drug placebo. No effect. 1 received the standard dietary information and the drug metformin, and a third group received intensive lifestyle intervention, which included a moderately low-fat diet and exercise plan to lose at least 7% of their weight. After almost 3 years, the lifestyle group had 154 THECHINA/dy. Chart 7.3, blood cholesterol on high carbohydrate, high fiber diet. Control IHCF diet, high carbohydrate, high fiber diet, N equals 14. V1. 100 type 1 patients. E. 1. Cholesterol O. U. 080. R. O. 60. -6 days. 58% fewer cases of diabetes than the control group. The drug group reduced the number of cases only by 31%. Compared to the control, both treatments worked, but clearly a lifestyle change is much more powerful and safer than simply taking a drug. Moreover, the lifestyle change would be effective in solving other health problems, whereas the drug would not. The second study also found that the rate of diabetes could be reduced by 58% just by modest lifestyle changes, including exercise, weight loss, and a moderately low-fat diet. 23. Imagine what would happen if people fully adopted the healthiest diet, a whole foods, plant-based diet. I strongly suspect that virtually all type 2 diabetes cases could be prevented. Unfortunately, misinformation and ingrained habits are wreaking havoc on our health. Our habit of eating hot dogs, hamburgers, and French fries is killing us. Even Dr. James Anderson, who achieved profound results with many patients by prescribing a near-vegetarian diet, is not immune to habitual health advice. He writes, ideally, diets providing 70% of calories as carbohydrate and up to 70 gm fiber daily offer the greatest health benefits for individuals with diabetes. However, these diets allow only 1 to 2 ounces of meat daily and are impractical for home use for many individuals. 20. Why does Professor Anderson, a very Diabetes 155 fine researcher, say that such a diet is impractical and thereby prejudice his listeners before they even consider the evidence? Yes, changing your lifestyle may seem impractical. It may seem impractical to give up meat and high-fat foods, but I wonder how practical it is to be 350 pounds and have type 2 diabetes at the age of 15, like the girl mentioned at the start of this chapter. I wonder how practical it is to have a lifelong condition that can't be cured by drugs or surgery, a condition that often leads to heart disease, stroke, blindness, or amputation, a condition that might require you to inject insulin into your body every day for the rest of your life. Radically changing our diets may be impractical, but it might also be worth it. 8. Common cancers: breast, prostate, large bowel, colon, and rectal. Much of my career has been concentrated on the study of cancer. My laboratory work was focused on several cancers, including those of the liver, breast, and pancreas, and some of the most impressive data from China were related to cancer. For this lifetime work, the American Institute for Cancer Research kindly presented me with their Research Achievement Award in 1998. An exceptional number of books have summarized the evidence on the effects of nutrition on a variety of cancers, each with their own particularities. But what I've found is that the nutritional effects on the Cancers I've chosen to discuss here are virtually the same for all cancers, regardless of whether they are initiated by different factors or are located in different parts of the body. Using this principle, I can limit my discussion to 3 cancers, which will allow me space in the rest of the book to address diseases other than cancer, demonstrating the breadth of evidence linking food to many health concerns. I have chosen to comment on 3 cancers that affect hundreds of thousands of Americans and that generally represent other cancers as well. 2 reproductive cancers that get plenty of attention, breast and 157. 158 the China study, prostate, and 1 digestive cancer, large bowel, the second leading cause of cancer death, behind lung cancer. Breast cancer. It was spring almost 10 years ago. I was in my office at Cornell when I was told that a woman with a question regarding breast cancer was on the phone. I have a strong history of breast cancer in my family, the woman, Betty, said. My mother and grandmother both died from the disease, and my 45-year-old sister was recently diagnosed with it. Given this family problem, I can't help but be afraid for my 9-year-old daughter. She's going to start menstruating soon and I worry about her risks of getting breast cancer. Her fear was evident in her voice. I've seen a lot of research showing that family history is important, and I'm afraid that it's inevitable that my daughter will get breast cancer. One of the options I've been thinking about is a mastectomy for my daughter, to remove both breasts. Do you have any advice? This woman was in an exceptionally difficult position. Does she let her daughter grow up into a death trap, or grow up without breasts? Although extreme, this question represents a variety of similar questions faced every day by thousands of women around the world. These questions were especially encouraged by the early reports on the discovery of the breast cancer gene, BRCAL. Headline articles in the New York Times and other newspapers and magazines trumpeted this discovery as an enormous advance. The hoopla surrounding BRCAI, which now also includes BRCA2, reinforced the idea that breast cancer was due to genetic misfortune. This caused great fear among people with a family history of breast cancer. It also generated excitement among scientists and pharmaceutical companies. The possibility was high that new technologies would be able to assess overall breast cancer risk in women by doing genetic testing. They hoped they might be able to manipulate this new gene in a way that would prevent or treat breast cancer. Journalists busily started translating selective bits of this information for the public, relying heavily on the genetic fatalistic attitude. No doubt this contributed to the concern of mothers like Betty. Well, let me first tell you that I am not a physician, I said. I can't help you with diagnosis or treatment advice. That's for your physician to do. I can speak about the current research in a more general way. However, if that is of any help to you, common cancers, breast, prostate, large bowel 159. Yes, she said, that's what I wanted. I told her a little bit about the China study and about the important role of nutrition. I told her that just because a person has the gene for a disease does not mean that they are destined to get the cancer. Prominent studies reported that only a tiny minority of cancers can be solely blamed on genes. I was surprised at how little she knew about nutrition. She thought genetics was the only factor that determined risk. She didn't realize that food was an important factor in breast cancer as well. We talked for 20 or 30 minutes, a brief time for such an important matter. By the end of the conversation, I had the feeling that she was not satisfied with what I told her. Perhaps it was my conservative, scientific way of talking, or my reluctance to give her a recommendation. Maybe. I thought, she had already made up her mind to do the procedure. She thanked me for my time and I wished her well. I remember thinking about how often I received questions from people about specific health situations, and that this was one of the most unusual. But Betty wasn't alone. One other woman also talked to me regarding the possibility of her young daughter undergoing surgery to remove both breasts. Other women who already had one breast removed wondered whether to have the second breast removed as a preventative measure. It's clear that breast cancer is an important concern in our society. 1 out of 8 American women will be diagnosed with this disease during their lifetimes, one of the highest rates in the world. Breast cancer grassroots organizations are widespread, strong, relatively well funded, and exceptionally active compared to other health activist organizations. This disease, perhaps more than any other, incites panic and fear in many women. When I think back to that conversation I had with Betty, I now feel that I could have made a stronger statement about the role nutrition plays in breast cancer. I still would not have been able to give her clinical advice, but the information I now know might have been of more use to her. So what would I tell her now? Risk factors. There are at least 4 important breast cancer risk factors that are affected by nutrition, as shown in Chart 8.1. Many of these relationships were confirmed in the China study after being well established in other research. 160. The China study. Chart 8.1, Breast cancer risk factors and nutritional influence. Risk of breast cancer increases a diet high in animal foods. When a woman has refined carbohydrates. Early age of menarche, first men. Lowers the age of menarche. Menstruation. Late age of menopause. Raises the age of menopause. High levels of female hormones in. Increases female hormone levels. The blood. High blood cholesterol. Increases blood cholesterol levels. With the exception of blood cholesterol, these risk factors are variations on the same theme, exposure to excess amounts of female hormones, including estrogen and progesterone, leads to an increased risk of breast cancer. Women who consume a diet rich in animal-based foods, with a reduced amount of whole, plant-based foods, reach puberty earlier and menopause later, thus extending their reproductive lives. They also have higher levels of female hormones throughout their lifespan, as shown in Chart 8.2. According to our China study data, lifetime exposure to estrogen is at least 2.5 to 3.0 times higher among Western women when compared. Chart 8.2, Dietary influence on female hormone exposure. Over a woman's lifetime, schematic. Woman's age. Plant-based diet. Animal-based diet. Common cancers, breast, prostate, large bowel 161. With rural Chinese women. This is a huge difference for such a critically important hormone. Point 2. To use the words of one of the leading breast cancer research groups in the world. 3. There is overwhelming evidence that estrogen levels are a critical determinant of breast cancer risk. 4. 5. Estrogen directly participates in the cancer process. 6. 7. It also tends to indicate the presence of other female hormones. 8-12 that play a role in breast cancer risk. 6. 7. Increased levels of estrogen and related hormones are a result of the consumption of typical Western diets, high in fat and animal protein and low in dietary fiber. 3. 13 to 18. The difference in estrogen levels between rural Chinese women and Western women 19 is all the more remarkable because a previous report 20 found that a mere 17% decrease in estrogen levels could account for a huge difference in breast cancer rates when comparing different countries. Imagine, then, what 26 to 63% lower blood estrogen levels and 8 to 9 fewer reproductive years of blood estrogen exposure could mean, as we found in the China study. This idea that breast cancer is centered on estrogen exposure 3, 21, 22 is profound because diet plays a major role in establishing estrogen exposure. This suggests that the risk of breast cancer is preventable if we eat foods that will keep estrogen levels under control. The sad truth is that most women simply are not aware of this evidence. If this information were properly reported by responsible and credible public health agencies, I suspect that many more young women might be taking very real, very effective steps to avoid this awful disease. The common issues. Genes. Understandably, women who are most afraid of this disease have a family history of breast cancer. Family history implies that genes do play a role in the development of breast cancer, but I hear too many people say, in effect, that it's all in the family and deny that they can do anything to help themselves. This fatalistic attitude removes a sense of personal responsibility for one's own health and profoundly limits available options. It is true that if you have a family history of breast cancer, you are at an increased risk of getting the disease. 23,24 However, one research group found that less than 3% of all breast cancer cases can be attributed to family history. 24 Even though other groups have estimated that a higher percentage of cases are due to family history. 25 The vast majority of breast 162 The China study. Cancer in American women is not due to family history or genes, but genetic fatalism continues to define the nation's mindset. Among the genes that influence breast cancer risk, BRCA1 and BRCA2 have received the most attention since their discovery in 1994. 6 to 29 These genes, when mutated, confer a higher risk both for breast and ovarian cancers. 33. These mutated genes may be passed on from generation to generation, that is, they are inherited genes. In the excitement over these discoveries, however, other information has been ignored. First, only 0,2% of individuals in the general population, 1 in 500, carry the mutated forms of these genes. 25 Because of the rarity of these genetic aberrations, only a few percent of the breast cancer cases in the general population can be attributed to mutated BRCAL or BRCA2 genes. 33 Second, these genes are not the only genes that participate in the development of this disease. 32. Many more will surely be discovered. Third, the mere presence of BRCAL, BRCA2, or any other breast cancer gene does not guarantee disease occurrence. Environmental and dietary factors play a central role in determining whether these genes are expressed. A recent paper 3 reviewed 22 studies that assessed the risk of breast and ovarian cancer among women who carried mutated BRCAL and BRCA2 genes. Overall, disease risk was 65% for breast cancer and 39% for ovarian cancer by age 70 for BRCAL women, and 45% and 11%, respectively, for BRCA2 women. Women with these genes certainly face high risks for breast cancer. But even among these high-risk women, there is still good reason to believe that more attention to diet is likely to pay handsome rewards. About half of the women who carry these rare, potent genes do not get breast cancer. In short, although the discovery of BRCA and BRCA2 added an important dimension to the breast cancer story, the excessive emphasis given to these particular genes and genetic causation in general is not warranted. I do not mean to diminish the importance of knowing all there is to know about these genes for the small minority of women who carry them. But we need to remind ourselves that these genes need to be expressed in order for them to participate in disease formation, and nutrition can affect this. We've already seen in Chapter 3 how a diet high in animal-based protein has the potential to control genetic expression. 0mm0n, N, ERS, BRASTF prostate F large bowel 163. Screening and non-nutritional prevention. With all of this new information regarding genetic risk and family history, women are often encouraged to get screened for breast cancer. Screening is a reasonable step, especially for women who may have tested positive for the BRCA genes. But it's important to remember that doing a mammography or getting a genetic test to see if you harbor BRCA genes does not constitute prevention of breast cancer. Screening is merely an observation to see whether the disease has progressed to an observable state. Some studies 36 have found that groups of women who undergo frequent mammography have slightly lower mortality rates than groups of women who do not undergo frequent mammography. This implies that our cancer treatments are more likely to be successful if the cancer is found at an earlier stage. This is likely to be true, but there is some concern over the way statistics are used in this debate. One of the statistics used to support early detection and the ensuing treatments is that once diagnosed with breast cancer, the likelihood of surviving for at least 5 years is higher than ever before. 37 What this really means is that with the aggressive campaign for regular screening, many women are discovering their breast cancer at an earlier stage of disease. When disease is discovered at an earlier stage, it is less likely to lead to death within 5 years, regardless of treatment. As a consequence, we may have an improved 5-year survival rate simply because women find out that they have breast cancer earlier in the disease progression, not because our treatments have improved over time. 38. Beyond the current screening methods, there are other non-nutritional options for prevention that have been promoted. They are especially of interest to women who have a high risk of breast cancer due to family history and/or to the presence of the BRCA genes. These options include taking a drug such as tamoxifen and/or mastectomy. Tamoxifen is one of the most popular drugs taken to prevent breast cancer. 39, 40 But the long-term benefits of this option are not clear. 1. Major U.S. studies showed that tamoxifen administered over a period of 4 years to women at increased risk of breast cancer reduced the number of cases by an impressive 49%. 41 This benefit, however, may be limited to women whose estrogen levels are very high. It was this result that led the U.S. Food and Drug Administration to approve use of tamoxifen by women who met certain criteria. 42 Other studies suggest that the enthusiasm 164 The China study ASM for this drug is not warranted. 2 Less substantial European trials 44 have failed to show any statistically significant tamoxifen benefit, raising some doubt about how dramatic the benefit really is. Moreover, there is the additional concern that tamoxifen raises the risks for stroke, uterine cancer, cataracts, deep vein thrombosis and pulmonary embolism. Although the overall benefits of breast cancer prevention are still believed to outweigh the risks, 42 other chemicals have also been investigated as alternatives to tamoxifen, but these drugs are encumbered by limited effectiveness and or some of the same troublesome side effects. 45.46. Drugs such as tamoxifen and its newer analogs are considered anti-estrogen drugs. In effect, they work by reducing the activity of estrogen, which is known to be associated with elevated breast cancer risk. 4.5. My question is quite simple: why don't we ask why estrogen is so high in the first place, and once we recognize its nutritional origin, why don't we then correct that cause? We now have enough information to show that a diet low in animal-based protein, low in fat and high in whole plant foods will reduce estrogen levels. Instead of suggesting dietary change as a solution, we spend hundreds of millions of dollars developing and publicizing a drug that may or may not work and that almost